Join us in 30 minutes for the 40th episode of TechLifeSkills with Tanmay, where we'll be joined by our special guest, Tanmay Bakshi, and he'll be answering all the questions we've been dying to ask in 2020.
That's absolutely right, Michael. There's so many questions that we just unfortunately don't get to take up on TechLifeSkills, but I'm going to be answering them today. Questions ranging from, how much math knowledge do you need for machine learning? How do quantum computing and supercomputing relate to each other? And what's the future of artificial general intelligence? So I can't wait to answer your questions. Make sure you join us in 30 minutes.
Join us in 30 minutes for the 40th episode of TechLifeSkills with Tanmay, where we'll be joined by our special guest, Tanmay Bakshi, and he'll be answering all the questions we've been dying to ask in 2020.
That's absolutely right, Michael. There's so many questions that we just unfortunately don't get to take up on TechLifeSkills, but I'm going to be answering them today. Questions ranging from, how much math knowledge do you need for machine learning? How do quantum computing and supercomputing relate to each other? And what's the future of artificial general intelligence? So I can't wait to answer your questions. Make sure you join us in 30 minutes.
Join us in 30
Hello everyone, and welcome to the 40th episode of TechLifeSkills with Tanmay. My name is Tanmay Bakshi. Thank you very much for joining me today. And I'd like to start off by wishing everybody a very happy new year. We finally concluded 2020, and this year has really changed how we live quite fundamentally, and hopefully things will start to get better going into 2021. Speaking of which, I would like to start 2021 by first of all saying a huge thank you to all the special guests who have been on the show for the past 39 episodes. Now, they've shared their time and experiences with all of us. I really appreciate it. And I'd also like to say a huge thank you to all of you for actually joining the stream. It really is your curiosity and the questions you ask and the feedback that you give that makes this show what it is. Now, I would like to assure you that I do go through all of your questions and your feedback after all the live streams. But the thing is, it can be difficult to answer questions on an episode that aren't related to a special guest's area of expertise or to that episode's topic. And that's why I hold every couple of episodes an Ask Tanmay special. Sometimes in these episodes we even just run out of time. And so in these Ask Tanmay episodes, my goal is to answer the questions that you all have for me. Now, in these past couple of years, I've gotten hands-on experience working with a wide range of different technologies. And I've also got to speak with leaders and experts in those domains actually building and working with those technologies every single day. Really leading the field. And so that's why, once again, we're going to switch it up a little bit. I'm going to be the guest on my own show so that I can answer your questions. And so now, I'd love to welcome your host for today, Michael Francis. Michael is a good friend of mine. He's been an amazing host, and so I'm glad to have him on. So, hi Michael, welcome to the show. How are you?
Hi, I'm good. It's nice to see you again and see everybody in the stream. Thank you, everybody, for tuning in. But, I'm the host, so I have to turn it back and flip it on you. How are you today?
I'm doing very well. That you are absolutely right. You are the host. You should have asked me how I know. It's Great to finally have you back on the show as well. And, this is something I'm looking forward to because every single stream, there are sometimes these questions that we can't get to, but I really want to answer, right? There's such interesting content. And so I do want to go ahead and answer those questions for you all today. Feel free to put them in the live stream chat. Feel free to go ahead and send them to us on any of these 3 platforms we're streaming on, at LinkedIn, Facebook, or YouTube, of course. And we'd love to go ahead and start answering your questions. I do believe we already have a couple, but Michael, I'm going to leave that up to you. So what am I going to be answering first?
Absolutely. So in true 2021 fashion, we're just going to get right into it. So hitting you with the hard question first, of course. How was your day? No, we're going to start with a question from Tazin, who asked, will AI take over humanity in 2045?
Okay, I absolutely love this question. This is a question that we do get actually quite a bit on a lot of the live streams. And we've also kind of covered some similar stuff on other episodes of Tech Life Skills with Tanmay. For example, we have talked about artificial intelligence and machine learning with Rob Hine, Sam Lightstone, who are IBM fellows, on the very first episode of Tech Time with Tanmay. And we've also talked to Ruchir Puri and Sriram Raghavan, executives from IBM Research. And so we've had a little bit of expertise on this topic, but really just to make it very clear and to target this question in specific, Tassin, I do want to sort of talk about the fact that artificial intelligence is very widely misrepresented by society. Right, and I'm going to say that as a developer, generally, it can be kind of it can be interesting, going about just everyday tasks and then seeing how people almost misunderstand the way that technology works. But there's no technology where that misrepresentation or misunderstanding is more evident or obvious than it is with artificial intelligence, I think. And the reason for that is because if you take a look at the way that AI has been represented for quite literally decades now, we've always seen artificial intelligence as, trying our best to get human level and, in a lot of cases, surpassing human level general intelligence in a computer. But the thing is that artificial intelligence as a word, one of the reasons that I don't like it is because it can be really, really hard to even just define the word intelligence, right? Like how do you know something's intelligent in the first place? What capabilities, what skills do humans have that you consider make them intelligent? Right? Like, for example, one of the things that we as humans are really good at is understanding and synthesizing natural language. So, all these thoughts in my head, I can convert them to language and you can understand that language. But the thing is that computers can now do, at least up until a certain point, similar capabilities, right? They can figure out what certain words mean in sentences. They can write very simple language as well. So are computers intelligent because they can do that? Not really. They're not intelligent in the same way that we think humans are, just because they can write simple, emails. Right? That's not the point. So I think what we first need to do is really understand what intelligence means, and when we start to take a look at what we really mean by intelligence, which is this general purpose reasoning and common sense reasoning, really capability. Then we start to see that artificial intelligence technology really isn't built in a way to support those kinds of tasks. It's a very fundamental problem with machine learning. We're trying to build a mansion on a foundation that really couldn't support a shack, in the sense of like reasoning, right? And so it would require a lot of fundamental going back to the drawing board to get AI to a point where it can overtake humanity, or even where it would make sense to ask the question, can AI overtake humanity? Because that question makes a lot of presumptions about, can we have intelligent machines that are intelligent like humans, in fact more intelligent, that we can't understand or can't control, right? So there are a lot of sort of presumptions that question would make, that the answer to which would be no, and therefore this question wouldn't really make that much sense to ask. So in brief, no, I don't think AI will overtake humanity in the next 100 years or whenever, 2045. And the reason for it is simple. It's because we have no proof today that it would be possible to, abstract away a lot of the internal working of a human brain and just have simple logic-based reasoning at a human scale. So, the day that we prove that that's possible, maybe my answer would change, but as of now, no.
Confirmed AI take over in 2046. It's actually interesting because I remember thinking, like, I remember hearing people talk about like the singularity in 2040 or in 2050, and how you're going to create an AI that, you know, like takes over the world and stuff. And then the more I actually learned about AI, the less sense that started to make.
Exactly.
And it's actually funny. I was watching, because people always tell me, you know, me being a tech guy, all my non-tech friends are like, hey, you should watch Black Mirror, for example. And I watched like the final episode that they have, the one with Miley Cyrus, and it's like how there's this pop star who has like this little, like a bot version of her, that you could buy, and it's like, you know, how was your day kind of thing. And it seemed to do an incredible job, and I know it's a show, but it seemed to do an incredible job of capturing what you're saying and dynamically speaking to you, like, oh no, you have friends, that's not true. It's like, when did people program these lines? And then the funniest part about that episode was they eventually get to a point where they plug it into a computer, and they find that the way they built this thing, I kid you not, is they downloaded the pop star's entire brain and put it onto this bot, and then locked it up so it was only a certain part of the brain that the bot was actually basically existing in. So it's they literally plugged it in, and then write a few, you know, enter your password here, and suddenly they unlock the entire brain of the person which exists in this robot. And it's just, no, that's not how it works.
Yes, because as a developer, I would totally write an entire system that we're going to lock the 99% of the capabilities of.
They literally had a diagram of like a brain, but then most of it was grayed out except for a small square in the corner. It's like, that's no.
It's not
But yeah,
how it works.
absolutely. With AI, it's like I say in general, you know, computer science is applied physics and physics is applied mathematics. So really, computer science and coding is just applied math, or just applied math in general. So, you know, maybe sure, it might be possible to build some sort of AI with this general intelligence that might take over humanity, but the amount of math required is just absolutely astronomical. Like, it's the level of math needed.
That's giving way too much credit to astronomy.
Yeah. It would literally, it's a large combination of, you know, I can imagine millions of lines of math, you know, code related to math we do know, and then millions of lines of code to math we haven't figured out yet.
Exactly.
So it's just to the point where it's just not feasible.
It's like, I mean, the way that I like to think about it, and, you know, there's a common rebuttal to this, and I'll get to that. The question is, or really the sort of issue here, is that even just simulating like a nanosecond of how a molecule like caffeine interacts with literally nothing in a total vacuum on today's fastest computer, like IBM Summit, would take you weeks. A nanosecond in a complete vacuum, caffeine, weeks of compute, all right? and caffeine's pretty small compared to what we've got in our heads. And we've got quadrillions, if not more, I think that's actually an understatement, of these individual molecules that are building up proteins and cells and the different chemicals that they use to interact and the electrical signals and so on that then make us. And hold on, let's just say even if, you know, we were to map out every single molecular interaction in the human body, and if we were to somehow create computers that were fast enough, you know, IBM Z mainframes running at, you know, 20 gigahertz or whatever, if we were to get really, really fast computers to do this, I mean, at the end of the day, those computers are still just calculators, right? I mean, if you were to write out those exact same mathematical operations, and if you were to sit there for billions of years and on paper calculate all of those mathematical functions, would you say that the piece of paper or the pen or you are now doubly intelligent somehow because you wrote down the mathematical operations that helped you, you know, get this sort of intelligent being? I mean, no, you probably wouldn't, because the paper's not intelligent still, even though it has that math written down onto it. Math is just a human construct, right? I mean, like when you simulate water in a virtual physics world on your computer, your CPU is not wet. So that's the way that I like to think about it. And then I really don't think we'll even get to the point where we can simulate all those mathematical operations. And so the general sort of consensus is that if we do reach the sort of AGI by simulating the brain, it's not going to be by simulating every individual molecular interaction, but rather by abstracting away some of the working. But then you have to think, is that even possible, right? Like, can you just abstract away the way that individual neurons actually interact and just say, we're going to do a matrix multiply? Like, can you actually do that? so, so there are lots of different issues to work out, but in brief, I don't think it's going to happen.
Yeah, everyone's like AI will take over the world. Meanwhile, CPUs are like division is hard.
Exactly.
It's so Akash actually in the chat he said two things. He said, Jarvis, just a rather very intelligent system. That's from Iron Man. I know that one well. And he also said this is Age of Ultron, where Ultron tried taking over the world. So funny story in a movie I think I'll eventually get you to watch. In the Avengers film, there's a movie called Age of Ultron, and this again is part of the series of things that happen in Hollywood that make people think AI is so dangerous. Where Iron Man, who his power is basically he's a super genius. He's a billionaire and he's a genius to the point where he solves time travel. But Iron Man, he says, I want to make like a suit of armor around the world. So he builds an AI that would be able to just protect the world from aliens or whatever might attack. And the AI wakes up, it immediately says, okay, well, my prime directive is to, save the world. And then it looks at the internet, it looks at human history, and it's like, oh, humans are the problem. So he decides to literally like leave the building, and he's like, okay, I'm going to kill all of humanity. This is the only way to keep the world safe. And that's where people are like, oh no, AI is bad. But just that leap in general, it's just like, okay, let's fix that. First of all, that's contextual, right? That's the context of we need to protect the world. But what is the world if your goal is to kill humanity, right? So there's something is lost in translation there already. And then for it to like read through the internet and history and then understand all of that and decide what to do on its, like it's a collection of, that's not how that works. So it's very interesting for sure.
Yeah.
Yeah, I was just catching up on chat. Everyone has some making some great comments and conversation. I absolutely love it.
Mm-hmm.
But shifting the conversation, because we do talk a lot about AI. So switching into our next topic, Shiva asks, how do quantum computing and quantum mechanics relate?
Ooh, very interesting question. So, I mean, first of all, really fundamentally, I mean, the way you can think about it is that, the way that physics works in the world that we live in is pretty obvious because, we've evolved over billions of years generally life has evolved over billions of years. We've evolved over millions of years to very easily, intuitively understand that, hey, if I, pick up something and if I, let go of it, it's going to fall, it's going to drop, right? We understand these sorts of things like gravity just sort of intuitively. They just come to us naturally because we kind of need to know about it to survive in the wild, right? But then, in the universe that we live in, when you get down to a really, really small scale, different particles and the things that make up the things that we see in the sort of larger macro scale universe are built up of particles that behave very, very differently. And what's interesting is that the computers that we work with today are built on those sort of classical foundations of physics, at least mostly. I say that with an asterisk because there are some quantum properties of even regular processors that you use in your everyday computers that they have to keep in mind because they're at such small scales, right? I mean, imagine a transistor at like 5 nanometers, right? You have to keep quantum effects in mind. But really the idea is that things like, for example, the caffeine molecule I was talking about that takes weeks to simulate on a classical computer, the idea is that, hey, if this is a task that takes weeks on a classical computer, could we rewrite the algorithm from scratch that does that simulation in a way to use quantum mechanics in order to solve that problem more effectively? Almost think about it like an FPGA. A field programmable gate array. FPGAs are like CPUs, except instead of already coming with like instructions written or certain gates or whatever on the silicon. It's just a bunch of programmable gates, and you can literally write code, and that code is a circuit, and you can flash a circuit onto the FPGA whenever you want, and you can run really, really fast stuff on there, right? Because it's no longer a general purpose processing unit. It is quite literally a circuit that you have designed and are just running directly. So you are running at the speed of electricity, or the speed of your gates, right? And so these FPGAs, essentially what you're doing is you're saying, okay, instead of writing logic that is then compiled to run on my CPU, I'm just going to write the actual circuit, right? I'm going to use fundamental logic gates in order to solve my problem. Similarly, with a quantum computer, you think, well, if I could use quantum mechanics to calculate something, then hey, why don't I just give those instructions of what quantum operations I'm going to run to a quantum computer, and it actually uses physical quantum bits made of quantum particles in order to run those operations and do that experiment for you, right? So before, if something like the double slit experiment would take tens of thousands of dollars of optical equipment and a lot of time to set up and make sure it's working right, now you could just create a quantum circuit and send it over to IBM right now for free on your phone if you wanted to, and you could run it yourself, right? Like if I wanted to run the time delayed quantum eraser, I believe it's called, right? It's a really fun experiment, but it requires like what, $30,000 in optical equipment? I'm not gonna buy that. I can just go to IBM, write out that optical experiment in a bunch of quantum instructions and run that on the cloud. And so, quantum computing opens up a lot of opportunities to run certain algorithms, not all, certain algorithms, that we couldn't run fast on classical computers to run fast using quantum mechanics on a quantum computer, right? That's the basic idea. That's sort of where they intersect. But of course, the answer is generally, pretty complex. That's a pretty high-level overview of, what quantum computing is all about. But that's generally sort of where quantum computing and mechanics intersect.
And this is the part where I take over. So with quantum computing, how the mechanics relate. So as Tanmay sort of leaned into is we understand the world as it exists physically. But this is what happens on a very macro scale, on a large scale when you're dealing with bodies and to an extent, when you're dealing with, small molecules as well. But in reality, once you get really, really small, what you end up finding is that physics doesn't work the way that we think it does. And this happens when you get really small. For example, for a very, very, very long time, we thought the atom was the smallest possible thing that you could have. In fact, that's where the name comes from. Atom, as in Adam and Eve. That's actually that's where the name comes from. It's the smallest common denominator. The thing is, the first, almost like the thing. So they called it the atom. But then we found that, while an atom has, like, for all my physics people or my chemistry people, my, neutrons, protons, and electrons, turns out that those things are also made up of other things. They're made up of quarks, and these quarks are also made up of other things. So things get really, really, really tiny. And what we find is that as things get tiny, they start to inherit certain properties that we simply just don't see. Mm-hmm. You might have heard of quantum tunneling, which, Tanmay was alluding to when you have the 5 nanometer transistors, is when you're dealing with such small objects like electrons, and you are dealing with the really, really, really thin walls like these 5 nanometer transistors, 2-3 nanometers. What you can actually have is these electrons pass through these transistors due to certain properties, like the fact that while we know, for example, this AirPod to be a little case, electrons can act as both waves and particles. So they could be a little ball existing in space, or they can be a wave of energy that's existing in space. And so all these sort of weird properties come together to create quantum mechanics. And where quantum computing comes in, comes from a mechanic that also exists in classical mechanics as well, is this idea that you can have 2 particles which are sort of linked throughout the universe. So as soon as you discover certain properties about one, that immediately tells you certain properties about the other, no matter how far away they are, whether it's on the other side of the planet, other side of the solar system, whatever the case. So usually in a regular computer where things are sequential, right, you have your bits and bytes and ones and zeros, where I have to read a certain bit and then move on to the next and then move on to the next. And I just read these bits really quickly. In a quantum computer, knowing a certain bit tells me the value of another bit automatically. Like, I don't even have to check what the other one is. I know for a fact this is what it is. So you can almost very naturally run things in parallel. And I remember when I, explained this before, someone had said, but can't we already do things in parallel? I mean, GPUs do things in parallel. Well, GPUs do things in parallel because they're designed to handle these certain processes separately. But when you're dealing with a quantum computer, something as basic as, like, hey, let's run a for loop from 1 to 10 and just add the numbers. It's able to sort of make that decision tree automatically and be able to say, okay, let's do all of these and figure out what is, the best route, because it's by its very nature parallel. We don't have to create it in some sort of way like a CPU. You don't have to create threads and cores and whatever. It's just by its very nature, it just exists as a parallel computer. So if you have this parallel computer and then you parallelize it, then it's like parallel squared or something.
The reason that I love that explanation is because so many people, whenever I talk about quantum computing, are like, but I mean, a supercomputer already has like millions of cores. Why don't we just use millions of cores? Why do you need like 12 qubits? Why would 32 qubits be better than a million power 9 cores, right? And the reason, I mean, as precisely you mentioned, is because, with a classical computer, I mean, think about GPUs. Right now, as I'm streaming this to YouTube, what's happening is, my computer over here is using software, which in this case, it's more than likely using FFmpeg or whatever libraries it uses behind that, in order to use my GPU to encode this video, send it over to YouTube compressed, and then YouTube is decoding it to show it on your device. But the thing is, every single pixel needs to be used for that encoding and decoding. And so, technically, you basically have to do the exact same thing to a bunch of little different squares of pixels, right? Groups of pixels. And so it's pretty easy to parallelize because you have like, let's just say random number, 1 million pixels. If you have 8 GPU cores, then you can do these in batches, right? You can do these in batches, and you're doing the same thing to a lot of these different batches of data. But then the quantum computing, the idea isn't that you have a lot of different data and you're going to do the same thing to all these pieces of data. Rather, you have one single task to work towards that may have, billions of possibilities as to what the output of this algorithm is, and you want to find the most likely output of that algorithm. That's where quantum computing comes in, right? Like, can we put these qubits in superposition in such a way that when we, when we collapse that wave function, when we actually take a look and measure the values of these qubits, can we figure out the output of the algorithm, as in, how is the caffeine molecule behaving, or, how did it move, how did it interact with whatever else it was, whatever else we were simulating it with, right? That's the idea. Is it's not necessarily parallel more than it is putting qubits in certain states where the probabilities of when we collapse them, measuring a certain value, overall those probabilities sort of make it as if the algorithm was parallel, right? It's kind of hard to describe because you can't really use classical terminology to describe something like this. It's almost a limitation of our language, I feel like. This is another reason that I'm so interested in language, right? Because the way that we describe these things, the words that we use, can really change the way that people understand it. But it's not really parallel. It looks parallel because of probability, but it is parallel because, when you compare it to classical, it's a lot faster.
Right.
So, it's interesting.
And to sort of bank off that, we have in the chat, Sesley asked, are there any examples of quantum computing solving mathematical problems that require an infinite amount of time on a classical computer? And to that, I say yes. Very easily, yes. One of the actual ideas in sort of like the baseline idea in like quantum cryptography, for example, is imagine, you had some server you didn't want someone to access to. And all you had to do to get access to the server is do a simple calculation. What's 1 + 1? Obviously, any computer will do that in nanoseconds, just 1 + 1, right? So that's straightforward. But as these numbers get larger, you might say, what's 2 to the 328 times 4 to the, 1,000, for example. As these numbers get larger, obviously, it's going to take a computer longer and longer to do. But by default, there are questions that a quantum computer can answer basically instantly, that a classical computer would take so long you just wouldn't even try it.
Yeah.
There's math problems that would take regular computers 100 years to solve, that a quantum computer will solve basically in a couple of seconds or minutes or whatever. And so it's not necessarily that there's this problem we haven't been able to solve where quantum computers is yet to jump in and save us, but something as simple as multiplication of really large numbers, or factoring. Factoring is a really great example. Factoring is the one that they use. They say, okay, factor this number. This is one factor. The answer is the other factor.
Actually, hold on. One thing I will say, just to sort of interrupt there. While you are right, there are a lot of problems that quantum computing can solve that classical computers can't. The only issue today is that we don't have quantum computers good enough to actually run those tasks. In theory, a lot of things should be possible that aren't possible today. And it's been proven at a small scale, right? Like IBM has, I believe, it's 50-qubit quantum machines that are really densely interconnected and work very well. But as in they have like low error rates. But the issue is that they're still not good enough to actually give you quality output. There's enough of an error in measuring the values of qubits, right? Like, I mean, superposition can only be held for a couple of microseconds at best, right? If you're lucky.
Yeah.
And so they're kind of inaccurate right now.
I think the error rate's 1%, which is, that's what I heard at least like a year ago or 2 years ago, 1%, which is pretty high for computers.
I think it's much higher than that.
Somebody got it down to 1%, but that's still pretty high.
In a lab setting, right? Not in like, everybody can use this now. But yeah, that's quantum computing.
And I guess to close it off with one more question about quantum is let's give the short answer to this because we've been talking quantum for a while, but is quantum computing better than supercomputing? And this is also from Sesley.
So again, I will say that it depends on a lot of different factors, and I don't think it's possible to just say quantum computing is better than supercomputing, because remember, it really depends on the task. Quantum computing is so much of a reinvention of computing, right, in the sense that we're literally changing the laws of physics on which these computers operate. That even simple things like, oh, I have an AND gate or an OR gate or an XOR gate, you can't take these things for granted. You can't just say, I'm going to slap a couple logic gates on this quantum circuit. Or you can't really do that, right? You have to fundamentally rethink the way that you design algorithms. So if you were to just take like a classical computer and reevaluate the function to run in a quantum circuit, it will more than likely be many hundreds of times slower. But if you were to take a step back and try and think, okay, what's my objective here? Is there a way that I can represent the output of this algorithm based off of the input in a bunch of quantum, spins and interactions between qubits? Then yeah, potentially can be much better than any of the fastest supercomputers. So it depends on the algorithm, it depends on the task, and it depends on what computers you're using. But overall, in a lot of cases, yes.
Yeah, it's very much so. It really does depend on the task. And to sort of close off the physics section of today, we have a question from Astronomy from Anas, who said, I love physics and do it the whole day, but my parents tell me to focus on school studies. I want to crack the International Physics Olympiad. What should I do? I don't know if you want to take a crack at this first or if I should, because I know I usually answer the school questions.
One thing that I will say, just to sort of start off, is because, I mean, first of all, one thing that I've always, sort of believed is that when you're doing something that you're passionate about, it sort of just comes naturally to you, right? And I mean, Michael, you know this firsthand. I really, really love code, and it's like literally, everybody. What happened this one time? Let me tell you all a quick story. Is that Michael sent me a video, right? And he had two sections of the video, and one was just like a raw video, and one was compressed with like I think Handbrake. And he was like, "Can you tell which one was compressed?" Because he wanted to figure out what the video quality was like. And I wanted to get the right answers. So what I did was I went ahead and took a couple of keyframes with a lot of different colors in them, copied them out of the video, loaded them into a Python script, and then looked at every single pixel value, sort of hashed it, and then I found all the unique colors in both videos and calculated basically the chromatic diversity of both the sections of video. And compression, what it does is it also quantizes colors, so more similar colors get merged to save space on the disk. And so I was able to figure out which one was compressed based off of chromatic diversity, even though my eye couldn't really tell. And so I tell Michael what I did, and the first thing I get back from over text is like, "What is wrong with you? Can you not code for 5 minutes?" So I really love code, and so this sort of stuff just happens naturally. That took me like 2 minutes to quickly spin up on Google Colab, right? So what I will say is that even though I am really passionate about code, there are still a lot of other things that I'm interested in and things that I do study just because the intersection of things that seem unrelated to what you're really passionate about can be really useful, right? Like when I learn how to code, I'm also really interested in machine learning. So being able to understand, some of the math behind machine learning, or things like linguistics for natural language processing, or psychology to be able to understand how humans speak, these things, even though they seem unrelated at first, can be incredibly helpful. So what I will say is that, in my opinion, if you're passionate about physics, it's something that you should definitely spend a lot of time on, whatever free time you have. If it is something that sort of just comes naturally to you and is fun, then it's not that you will need to take out the time, you will be able to take out the time because it's what you'll want to do, right? But at the same time, I do think it is also important to be able to focus on different subjects that you're learning, and this all sort of depends on your age as well, but also is important to be able to focus on those things, even if it's comparatively less, to be able to sort of gain insight from those intersections. So that's what I think. But Michael, what do you think?
Yeah, absolutely. I'm in line with that. What it comes down to, so actually, I'll start this with a little story that isn't related to Tanmay and I. A lot of people love Steve Jobs, so I whenever I can, have a story about that, I like to throw that in there. So I don't know how many of you have actually read the book on his life, but I learned a few interesting things reading that. But one of the important values I took from that is the fact that being successful in your field doesn't necessarily come from being a master in your field, but rather it comes from combining fields. And I always say I pride myself in being a jack of all trades. I know a little bit of everything, and I'm not really a master of anything.
This has come up multiple times on the show. A lot of people forget the last part of the quote. It's a jack of all trades, but a master of none is oftentimes better than a master of one. So
there you go.
Yeah.
And what happened with Steve Jobs is while he was attending university, he would pop in classes that he didn't actually enroll in. And one of these classes that he really liked was a calligraphy class. And for those who don't know, calligraphy is I wouldn't say the study of, but it's basically the way that you write stuff, and the way basically writing font by hand. That's the easiest way to describe it. We're all computer people here, so basically making fonts by hand rather than obviously on a computer back in the 70s or 80s whenever he went to school, 70s. So he would take calligraphy classes because he really liked it. And that would come in handy for a few reasons, because when it came to build a computer like the Macintosh, fonts were really important to him. He said, I really want people to be able to customize their computer. I need fonts. But also some of the ideologies he picked up sitting in the back of these classes were built into the design language of the Macintosh itself, into the operating system, into the actual physical computer. And this is, to me, it's a really strong example of why it's important to, take a dip into some other fields. Because if he hadn't gone to these calligraphy classes and been so inspired by what he learned in these classes, the design language of Mac would be very different than it is today, right? It would have been much harder for, remember, his goal was to connect humans and computers to make it easier, for computers to be used by people. Because back then, if you used a computer at all, you were a nerd, right? Now you might be a nerd if you write a lot of code, but if you had a computer, you were a nerd, because you just had to know all this technical stuff just to be able to use it. So that design philosophy was aided by his ability, to learn these things from his calligraphy class. And when it comes to physics, it's like I sort of mentioned earlier, where I said computer science is applied physics. Physics is applied math. And math is a very, very, very important part of physics. I give you another story. This one's shorter. In first year, we had a professor in our physics class for both mechanics and for electricity and waves. And what he would do is, okay, here's a problem on the board. Jack is sliding down a hill at a certain speed, calculate his force, blah, blah, blah. And he would, he'd wait for people to answer. And then he would put up on the board, it's like, okay, here's what you have to consider. Here's your diagram that shows all the forces. And then he would just throw up a bunch of, numbers and equations. He says the rest is math. And he doesn't go over the math of the problem because it's like, you should be able to do the math. What I'm going over is the concept and how you get to the stage where you do the math. So every single question you get, you have some circuit with some capacitor here and, some, battery there. And then it's like, okay, what's the answer? What's the voltage at this point? And then he'll pull it out. He'll, click the next slide and say, okay, you have to consider that this capacitor does this and whatever the case, and the rest is math. He doesn't actually show you how to get the number, right? So for example, if you really love physics, then studying math is equally as important because you can know the concepts, really well from a conversation standpoint, but being able to actually solve these problems requires a knowledge in math. And if you want to, for example, one day solve a physics problem that hasn't been solved before, or only a few people can solve, having insight to the way things work in other areas, maybe even something as, seemingly unrelated as history, right? Having knowledge and insight or general ideas of things that have happened in other areas that you learn in school can actually prove useful when you're approaching a problem that hasn't been solved yet, right? Using insight that most people approaching it don't have. Mm-hmm. So in my opinion, yeah, very much, have that passion for physics. It's great that you love physics, but also you should, be concerned with your school as well. Don't fall behind in school because you're doing physics. You can always in a few years, you can always, go to school and study physics, right? You can go to a university or college and literally all of your classes are physics related. But until then, you need to be able to do well in your language studies and your math studies and whatever else classes you have. You need to be able to have those fundamentals as well. Mm-hmm. Yeah,
yep.
That's
those fundamentals
long part.
are definitely important. But again, it really does depend. And what's interesting is, again, if you're really passionate about something, it's fun to be able to find intersections of what you really like with what else you're learning, because that's where real innovation happens, right? I've said it time and time again. Exponential innovation, right? The fact that we as humans have sort of innovated so quickly, so much so quickly, has made it so that within individual fields, sure, there is scope for innovation left, but it's a lot less than there is at the intersections of those fields, right? Like, we've done a lot in math, we've done a lot in computer science. Now the real innovation is happening at the intersection with machine learning, right? We've done a lot with linguistics and a lot with computers, but now the real innovation is happening at the intersection of those two, natural language processing. So, I feel like those intersections are fun. Same goes with physics. If you're passionate about it, learn more about it and see how you can innovate.
Yes, absolutely. And our next question is from the chat. We have Akash who says, in the last 2 to 3 years of developer surveys, the Rust language has been one of the top most popular languages. What makes it so special when it's just a system language?
Ooh, I love Rust. So, what makes Rust so special is the fact that it's a system language that doesn't read like a system language. It's like, you expect something like Rust to be ridden with, little pitfalls that you would never see coming, riddled with undefined behavior, riddled with memory issues, and all these things, but Rust has none of it. Rust is safe. Rust is fast. Rust uses LLVM to compile. It is pretty much everything a developer could ask for. I will say I would work on the syntax a little bit personally, but apart from that, Rust is an amazing language. Particularly, now, the way that I like to think about it, and really my two favorite languages in the world are Rust and Swift. And a very, very close sort of, basically in the same group is also Julia. You'll notice that, first of all of these languages are compiled by LLVM, but that's separate. Now, the thing that I really love about Rust and Swift is because if you sort of think about the sort of the idea, the fundamental sort of vision of the people who built these languages. They had these ideas like, we want to convert as many warnings to errors. We want to make it so that developers write code that crashes at compile time, not runtime. We want to write code that is extremely safe. We want to write code where memory is handled automatically so that people don't need to do it manually. We want to write code that can interoperate with C and C++. Right? These sort of fundamental ideas or values. Both languages have the exact same values. The only difference is that Swift is backed by Apple, and therefore it needs to fundamentally still be a little familiar, right? It can't feel like an alien language to any developer because Apple needs developers to use it for Apple apps. And so they're like, don't worry, it's not that much different. You can jump ship, right? But then you take a look at Rust, and they were like, we're going to forget everything we know about programming. We're going to go back to the drawing board. And they invented a whole new kind of memory management called ownership, right? So at first, I will say that trying to understand how the Rust syntax and ownership and memory management works can be a bit of a pain. But once you figure it out, Rust is an incredibly powerful language because it has that same extreme safety and, developer convenience concerns that Swift does, but at the same time, it doesn't even have the overhead of automatic reference counting. Like it's literally pretty much exactly what you would ask for as a developer. It's like you got a single malloc, a single free for everything. There's no extra counting. There's no extra garbage collection. At compile time, it'll automatically put the frees for you because it knows, thanks to ownership, where things need to exist. And it has 3 intermediate stages of compilation. Right? Swift has Swift Intermediate Language, LLVM, assembly. Rust has Rust to 2 other intermediate languages, to LLVM, to assembly. So they can optimize your code way better than practically any other language can, right? They're extremely well known for their optimizations. So one of the reasons that Rust is so popular is just because developers love it, right? The people that do work with it really, really like it. It's one of those communities that is strongly biased towards positive feedback on Rust. And the whole community is more well-knit than it is for a lot of other languages as well. So I would say that it's an amazing language. That's why it's at the top. But even though it is just a systems language, you can use it for so much more than just systems. Right? It's not like C. You can write a web app in Rust if you wanted to.
You see, I've never coded in Rust, so next question. No, it's that seems to hit all the marks. It's when you look at the you see like the most popular languages, but when you look at, for example, what are the most common languages asked for in a job, and I was telling this with Tanmay too, it's a lot of job applications for like backend roles, for example. They say, okay, we want Java, C++, or Python, and it's not because the employer is like, oh, my Java is just this incredible language. That right? What it comes down to is a lot of these languages we use now that are quite old. There's a lot of legacy systems that run on them. And there's a lot of course, given so much time being around, like C++ is, I think we said almost 50 years now, 48 years. There's a lot of libraries and optimizations that have been made over the years and different compilers you can use. So it's not necessarily because developers find them to be the best languages. I know Tanmay keeps telling me I'm going to eventually hate C++. It's more so because of the fact that it's just been around for so long. And everything that comes with that. But when you look at a language like Swift and Rust, Swift especially being so new, they end up saying, okay, like if we're going to do something new, let's do it right. And like you said with Rust, they go back to the drawing board on how you even think of writing code. Mm-hmm. But that absolutely sounds like, that's what the developers are looking for, is something that just works for them rather than something that just we use because it's always been around. Our next question is from Only. I believe this is in the chat as well. It says, hi, which language is best in terms of compatibility with the mainframe of COBOL for modernization?
Speaking of things that have been around forever. So COBOL is one of those programming languages that doesn't seem to die. No, during the sort of COVID pandemic, I believe it was the state of Michigan, correct me if I'm wrong, anybody in the chat, that was like, we literally cannot work on, they had some pretty fundamental programs that they had for their citizens that they could not get running because there simply weren't enough COBOL programmers for them to hire to work on it because they just didn't exist anymore. And the reason for that is because even though maybe the jobs exist for COBOL, developers hate COBOL.
Yeah.
It's like they really want COBOL to not exist anymore. But these mainframes that companies have bought literally decades ago are still running, and they're still running the same code that they were decades ago, probably without ever having been turned off. And so, a lot of the cases, these enterprises will say, let's not update our software, let's just keep it running because it works, until they kind of have to. So which language is the best in terms of compatibility? I probably am not in the best position to say because I haven't used COBOL, right? I'm 17. I don't think a lot of people under a certain age really use COBOL anymore. But I haven't used COBOL, so I wouldn't be the best to say. My best estimates would be C and C++ because they seem sort of the closest to be able to interoperate with these COBOL binaries, as well as the fact that you said mainframe. So I'm going to assume you're using an IBM machine, unless you're using one of those Fujitsu mainframes from the 1970s or whatever. But if you are using an IBM mainframe, then they do provide the compiler tooling, and I believe the tools to also manage interoperability between COBOL and other languages. So while I would say it's best to just completely modernize and not need to interoperate with COBOL, if you do, then I believe C and C++ would be your best bets. However, I will say that take that with a bit of a grain of salt and do a little bit more research into it because I'm not a mainframe expert just yet. There is something coming up very soon, in less than 7 days, where you'll see me working with a mainframe. It's actually an event called The Human Code on January the 9th, so I will put a link to that in the description. Make sure you join us. Should be fun.
Yeah, definitely tune in on January the 9th for that. It's going to be absolutely, it's good to see Tanmay talk, to be honest. So with, it's actually from New Jersey. I'm reading about it now. And it's funny because the very first line of this article says, New Jersey is throwing up the bat signal for the 60 plus programmer cloud. So yeah, if you're 60 years and older, then definitely COBOL is a language to use. It was the most widely used computer language in the world in 1970. So if you were writing code around the time C++ was created, then yes, absolutely, New Jersey is looking for you. So yeah, that's just exactly everything Tanmay was saying. It's a funny situation that they had there. And we have another question from Akash in the chat, I believe, as well, which says, Tanmay is writing a book on Golang, but it isn't his favorite language? Question mark. What is going on? Give us all the details tonight at 9.
No, it's 11:49. No. So I will say that I work with a lot of different languages. You may have actually seen a couple of months ago when I did live streams with Omer where we were live coding, which we'll be doing more of, by the way. That is coming up soon. When I did these, I was basically learning Go on the live streams almost. And you will notice that in a lot of these cases, I may complain sometimes about maybe the syntax, or maybe the way that the language works, or the fact that it doesn't have pretty fundamental primitives for very simple operations built in. But then the fact is that every language has pros and cons. I'm sure if I tried hard enough, I could find something bad about Swift too, although I might be hard pressed to do so. No, I'm joking. There's definitely a few things I don't like about Swift. Slow compile times being one of them. So while I will say that really my sort of really good languages, or ones that I like a lot, would be like Swift and Rust, because they really are attractive to me in the sense that the way their compiler works, and the way that they optimize my code, and the way that they allow me to write code, right? I like that. With Golang, it sort of doesn't hit the same fundamentals that I enjoy, right? Go is like, we want to compile code really fast, and we want it to run moderately fast, but we're not going to invest too much time in optimization. So while it isn't something that I'm personally very interested in, I do see where it's applicable and where it makes sense to apply Golang. And so I do like Golang in the sense that it makes sense why I would use it, and I would use it if I was writing that kind of application. But if I'm just going to pop up a script and write an algorithm real quick, I'm not going to pop up Go to do it. I'm going to use Swift or something. So even though Golang isn't my favorite language, as in it's my go-to whenever someone tells me to write code, it is a tool that I use, and it's my favorite tool for that specific job, which is back-end development that needs to use, containerization or concurrency at a very large scale at the user space, right? So these sorts of things require Go. But yes, that book is coming out very soon. It's the second book in the Tanmay Teaches series with McGraw-Hill. The first one was, of course, Tanmay Teaches Julia, and so the second book in the Tanmay Teaches series there, it's going to be on Go. So it's coming out soon. I'll put a link in the description.
Actually, yeah, that sort of answered another question from. I'm going to butcher this name. I apologize, but Yatsna. I think it's Yatsna. And the question was, how do you start learning artificial intelligence? Is there any book that you would prescribe? And we have one right here, Julia for Beginners, a springboard to machine learning for all ages.
Yep. I will say my favorite example, this is something that I show, whenever I'm talking about machine learning, especially in Julia and with this book. What this book does is it teaches you how to program from scratch. Well, not literally from scratch, the program, but, assuming you've never programmed before. And at the end, I also show you how to implement some pretty simple machine learning algorithms and sort of talk about how machine learning works. And one of my favorite examples is I also implement the deep dream algorithm, which you can see here. You can
lower. Oh wait, no, yeah, other camera. My bad.
Yeah, other camera. Yeah, you can kind of see over there the kinds of fun images you can create, and I sort of show you how the math works, and at least enough to sort of get you to not be completely clueless with the code, right? So I don't. This isn't a math class, but it is a programming class, and it does teach you how machine learning works, gets you sort of introduced to it at the end of the book. So that's definitely something I'd recommend, as well as the Learn Deep Learning from Scratch series on my YouTube channel. In fact, there was another question. Unfortunately, I'm forgetting who it came from. If I find, I'll mention your name. But there was a question, I think it was from Akash, mentioning, when is the next video in that series coming out? Very soon. It is something that I'm working on, and a bunch of videos will be coming out, as well as different exams that you can take with those questions, with those videos. So do stay tuned for that. And yeah.
I just realized it kind of looks like I'm hopping on one side. I'm just tapping my foot trying to fix my chair. My chair keeps moving. So if anyone's wondering why I'm hopping around like this, it's trying to fix that. But our next question is actually also from the same person, Yatsna from the chat. I actually like this topic very much. So they asked, if we're using AI to do a particular task, where initially that task was performed by a human, won't it be proved as a loss for that particular person? Like, won't they be losing their job?
Love that question. So this requires a pretty fundamental rethinking of the way that human society is structured, I think. And I think you might think at first glance that that's way too much of an overreaction. It's like, yeah, sure, we're going to use AI to replace some things, but we don't need to rethink the way that society is structured. We kind of do. And the reason I say that is because think about Slovakia for a second. I was there for a keynote for the American Chamber of Commerce. And while I was there, one of the folks that I sort of invited me to the event and that I was talking to told me that it actually is a pretty popular job there, just for people to sit down and copy shipping tracking numbers from one page to another. And I was like, that's a Python one-liner. Why is that a job? And, you can kind of understand that, first of all, it's a good thing that that job exists in a way, right? In some sense, because, sure, someone's getting paid to do it and they need that money. That makes sense. On the other hand, it's a really bad thing that that job exists. Because the fact that that job exists means that whoever is working in that area isn't working in another place where they're genuinely contributing to pushing the state of the art with humanity and what we can do and what we can accomplish. That doesn't even need to be like a scientific field. I don't even mean like, I want everybody to start doing a PhD. Like, that's not my goal, right? You could be an artist. You could be a cancer surgeon. You could be a programmer, whatever. It doesn't really, you could be a physicist, right? But you're doing something that is genuinely contributing to humanity's sort of knowledge pool or in some way working towards it. Now, the fact that these jobs exist almost gives governments and educational institutions sort of like a free pass to be like, even if our education system isn't that good, people are still going to get jobs because they can just copy shipping numbers from one page to another, right? But when we start to use AI and technology to automate so many things that previously were things that we did just as like the infrastructure of humanity, when we offload the infrastructure to technology so we can take care of actually being humans, I think at that point we're going to be fundamentally forced to make it so that education is incredibly effective. Because any government, right, any country that isn't able to figure that out and make it so its citizens actually know stuff and are able to find a job in a world where these sorts of mundane jobs don't exist, that country's not going to last very long. So they fundamentally will have to start rethinking these things. So I think it's a very good thing for the general sort of long-term progress of humanity that we are using AI to automate a lot of things. And you're right, in some cases, people are going to lose jobs because of AI. But it's a lot less than you might think, first of all. And second, in a lot of these cases, AI is going to make human jobs easier. It's going to make them better, right? Instead of doctors having to do so much paperwork and having to manually go through and find new research and academic evidence for different things and being able to come up with their own ideas and decisions, they can start to use AI to sort of automate a portion of that progress.
I couldn't hear what you said.
Speaking of AI, when your watch thinks you said the wake word.
That's what's taking your job, my guy? You lost your job to that? No.
No, so see, that's the thing. AI is not as good as you think it is. Right? My watch thought I said the wake word, which I'm not going to say now. Otherwise, it's going to go again, and everybody else's probably will too. But that's exactly my point. Is that AI is meant to replace some fields, augment a lot of them, and very few it just won't be able to touch because of fundamentally how creative they are. So that's really what I say is that for the long term, it's a good thing that it's going to replace some, right? And it's not going to happen that quickly. We do have time to see the changes that are inevitable and start preparing for them, planning, and actually changing the way that we live and the way that we educate. So I think it's a good thing.
Yeah. And from my experience dealing with automation and hyper automation, which is applying machine learning and AI to automation, a lot of people think, like, especially with automation, for example, like, oh, they're going to automate this job and people are going to lose their jobs, like factory workers or truck drivers or whatever the case. And it's not exactly the case. What you learn when you deal with, automation and what they call the future of work, like as in that's an actual title, you capitalize those first letters, the future of work. You have what you call your digital workers, and these are these machine learning or these AI or automation programs that do these tasks, like copying shipping labels from one thing to the other. And to me, it's just as people will say, and Tanmay will tell you, that we're moving to specific compute. Where we're designing chips to do things very specifically rather than general purpose. What having a digital worker allows you to do is do specific things in the workplace instead of doing these repetitive tasks like copying things. Imagine if that was just one of your many job responsibilities, was to copy shipping labels. Now you get more time to do the other responsibilities because you don't have to worry about copying labels. And a lot of people are starting to say, like, oh, university degrees are getting phased out. And I'm not telling you degrees are useless, but there are people who will argue that there's really no point in going to school and getting a degree because whatever the case. And where that sort of comes from is this idea that and actually the reality in most countries is when you go to university, you learn very general knowledge, especially because university is so theoretical. You learn general knowledge, but what's important when you're actually on the job is having specific expertise in specific things. That's why even with a degree, people are looking for experience, right? Because experience in a certain field shows you have a specific understanding of certain things. And so as we continue with AI and as we continue with automation, what ends up happening is people who have this general knowledge of computer science, for example, like, hey, I went to university, I have a degree in computer science. This general knowledge is at one point not going to be sufficient enough. It's like, okay, cool. You have a general understanding of languages from, Python all the way to C++ to Swift to Rust, but we need someone who's just really good at Java. And you're like, well, sorry, I've only done a little bit of Java, right? And so what universities and school in general, all the way from kindergarten to university, what they have to realize is we're moving to a more specific world where you can no longer just teach the general thing and good luck, but they need to be specific, because automation and AI is going to take over these repetitive tasks. People are going to be looking to hire people who can do specific things. So yes, for example, if your job is to drive a truck, and that's the only thing you do, you may not keep your job because they're going to have a self-driving truck from Tesla or whatever that drives running on a battery. But who's going to load the truck, right? Who's going to make sure that the truck is getting to its destination? Someone has to be paid to watch the truck's to watch its position and make sure it's actually getting to its destination without, right? So that actually creates more jobs, because now this
Someone
person
has to be
who's
paid to maintain the trucks.
exactly, right? So where you think, oh, the truck driver is going to lose his job, but there's actually 5 or 10 jobs being created in order to maintain that one truck or the systems of trucks. And it actually is more cost beneficial, because you're able to make a system where you're actually, as a company, making more money, even though you're hiring these more people. So yeah, absolutely, it's what it comes down to. If you're thinking of, oh, this person is going to lose his job, that's too small of a scale, because while a bot might replace this person's job, now people have to be hired to maintain this bot. So yeah,
and to build the bot, and to label the data for the bot, and so
exactly.
on and so forth.
So it always creates more jobs than it destroys. That's what that summarizes.
There are going to be entire industries in the future that we don't even see coming right now. There's no way that I could tell you what they are, because we fundamentally don't know. But there will be entirely new industries opened up by the fact that we have self-driving trucks that we don't even know exist yet. And those fields in the very beginning aren't going to be entirely powered by AI. They're going to need humans. And when we eventually need, artificial intelligence to replace the humans in that field, suddenly we're going to have more industries, right? So things are going to change, and things are going to evolve really quickly. And we're going to start to see a lot more places for people to work. And these places are fundamentally going to be places that require more of that human creativity and imagination and decision-making capability, more than just, hey, I got to drive this truck because it's fundamentally has to happen in order for human life to continue, right? So, it's going to be a lot more important directly to contributing to the next step that humanity takes.
Absolutely. But moving on to the next topic, we have Akash in the chat who asks, what are the prerequisites for your next book on Golang?
Yes.
Is programming experience specifically necessary for Golang?
So this book is a little bit different from my other books. It assumes you've never coded in Go before, but it does assume you have some coding experience. Could be with Python, could be with Swift, doesn't matter what it is. Preferably, I would say preferably a statically typed language, so you know how things like type definitions and things work. But overall, any programming language that you already have experience with, so you know how things like loops and conditions and functions and structures work. If you know that, you're good to go. I do explain some of the fundamentals again in the book, but it does assume you have some kind of programming experience with another language. But you do not need to have coded in Go before.
Fantastic. There you go. Be on the lookout for the next book. We have another question from the chat. This one's from Paul. And Paul says, hello, Tanmay. Planning on focusing on blockchain. Where can I explore more? And how is the scope?
Ooh, okay. Michael and I were just talking about this yesterday. There's a really famous flowchart. It's a sort of like a decision-making flowchart. It can help you make a decision as to whether or not you need blockchain. So you start off with, this block, do I need blockchain? And it just points to another node that says no.
Yeah, I'll find that picture. I will.
Yeah, find it. The reason that I like that picture so much is because even though it is slightly inaccurate, there are some cases that do need blockchain. I will say there are a lot of people that try to apply blockchain in fields where it's not necessary. Then again, your question wasn't where to apply it. How can you explore more? I will say that with blockchain, one of the great ways to get started, just to sort of generally learn more about the world of blockchain, would be my TechLifeSkills episode on blockchain with Andy Martin and Timothy Duncan. They're two folks that I know do a lot of great work with blockchain. Andy is a worldwide executive at IBM that focuses on blockchain and business. And so I will link to that episode as well down in the description. As well as a couple of other resources that we have on that topic. There is a cognitiveclass.ai course, completely free, that you can take on the world of blockchain as well that I will link to, that you can take a look at. So I will say that it kind of depends on how you plan to focus on it. Is it more from a business perspective? Is it more from a technical perspective? If it is more from a technical perspective, then 3 Blue 1 Brown's video on how cryptocurrencies work is a great way to get started. Learn more about sort of the technical aspects of how hashing and blocks and chains work. So I will link to all those in the description. So
Absolutely.
that's one of the ways you can learn more about the world of blockchain.
Yeah, because I honestly didn't know where to start either. So that's thanks for asking that for me. But I have the picture here actually. I think it might be too bright. I don't think this camera focuses, does it? There it is.
I can kind of see it. Yep, there we go.
Do I need blockchain? No. That's your diagram. It just points straight to no. There are no options.
I will say that's kind of a joke. We don't mean that seriously, but
yeah,
in a lot of cases, it can. When people that are like in business that don't really know about the technical angle are like, let's move our database over to a blockchain, right? That's when you pull out the flow chart and you're like, no.
From a technical perspective, it's always good to learn, and especially blockchain because it does have its use cases. But the joke is there's a lot of people in business or a lot of people who don't really know how blockchain works and what the pros and cons are, and it's just like blockchain. One of those buzzwords really that happens in the industry. It's disruptive. It's our next question is from Tassin, who asks, if there was no pandemic at this moment, would the entire population be as dependent on tech as we are now? It's a great question.
That is a good question, and I will say that we've always been pretty dependent on technology as a species, honestly. Arguably, even if you go back to when we initially evolved out of our common ancestor from, I think it was chimpanzees or orangutans or whatever, back when we evolved from those common ancestors, eventually when we started reaching closer to levels of modern humans, we only really survived because we were intelligent enough to create the tools to help us survive, right? Fundamentally, as humans, we're not really that special. If you put a single human out in the wild today...
Opposable thumbs intensifies.
Okay, maybe that. 2 thumbs up to that. But, okay, apart from that, actually, even with that, right? If you think about it, you just put a human randomly in the wild, it's not going to survive more than a couple of nights, if it's lucky. And the reason for that is because fundamentally humans are meant to be intelligent enough to work together and also intelligent enough to socially figure out solutions to problems using the environment, right? Not just being able to work in the environment to be able to survive, but to be able to use the environment to survive, right? To be able to say, hey, there's a stick. It's pretty sharp. If I jab an animal with it, it'll die, and then I can eat it, right? Being able to put together, I know that seems really primitive today, but back millions of years ago, being able to put together that logical reasoning was huge. And we could do it because we're humans. And so we were able to sort of figure out how to survive. So even back then, we were pretty dependent on technology, and fundamentally, as a species, we always have been. I will say, though, the pandemic has sort of increased our dependence on technology, but I'll also say that that's a good thing. And the reason I say that is because, think about this. Imagine we did not have to have people, for example, out there driving trucks or being cashiers at grocery stores. Or even shelving things at grocery stores. Imagine if that was all replaced by robotics and machine learning algorithms. There would be so many less people out there right now getting sick and spreading COVID more, causing more deaths and more people going to the hospital, meaning that the government needs to spend more money on making sure that they can actually keep up with the healthcare for those people, right? And then you might think that, well, in that case, how would they be paid? Well, if you think about it, the government's already spent billions of dollars on the fact that people are getting so sick from COVID. If everybody just stayed home because they didn't need to go out to work because of the fact that we can have machine learning doing that, those billions of dollars could be going to people instead of, the infrastructure to keep people from getting sick. So I will say that the pandemic has sort of increased our dependency, but I can only hope that we continue to increase our dependency in a way, because it's not like we're going to forget how to become cashiers at grocery stores. If people need to, they will. I'm sure in some rural areas there still will be. I'm sure that in certain countries there still will be cashiers at grocery stores. But if we can reduce the number of people, especially in the middle of a pandemic, that need to go outside and need to get sick and need to transmit COVID, all the better, right? And it would, at the end of the day, save money, and still people would get, the same kind of lifestyle that they have. So I think it's important to realize that being dependent on technology isn't a bad thing, right? It's not that we're dependent on technology and therefore we are inferior as a species. That is precisely our strength, is that we are dependent on technology, is that we can build that technology to be dependent upon. So think of it as a strength, not a weakness. Now, of course, that also means that our technology needs to be reliable enough. Now, that also doesn't mean that we all need to start putting IBM Z mainframes that can, survive an entire blast of cosmic rays, but still, our technology needs to be reliable and robust. But overall, I would say think of it as a good thing.
Yeah, and the pandemic has, I wouldn't say increased our dependency, but sort of accelerated that dependency, or accelerated our use case. For many, many, many years now, people have said, for decades, I'd argue, people have said the future of education is online. The future of education is online, future of education is online. Here in Ontario, in order to finish high school, your course requirements, you have to take 32 courses in 4 years, so about 4 courses per semester. So you have to take 32 courses in high school to graduate. And our premier, Doug Ford, he said, okay, when we want to change the high school rules, we're at mandatory, 2 of these classes need to be online classes, right? And this was before COVID, right? So he said, you have to take 32 classes to graduate. We want 2 of them to be online. Teachers were livid. They went on strike. There was a whole shutdown because they were saying, how dare you try to take away our jobs? And that, because 2 of the 32 classes he had asked to be online instead. Now we're in a pandemic and all of our classes are online, right? So, and it's crazy because, that's, again, everyone's saying the future of education is online. Suddenly a pandemic forces us to make education today online. So instead of the future of education, it's education now is online. And I know a lot of people are excited to go back to in person, but honestly, it's just because of how quickly things have happened that the systems haven't really been in place. I know as a university student, when we had the shutdown in March, it was like, okay, yeah, we got to close the university. It was very, like, a lot of profs didn't really know what to do. They literally had a couple of days to figure out how they would continue the course online, even though a lot of courses have like lab components where you actually have to be in person observing some reaction or whatever the case. Suddenly everything had to shift online. But now that it's, January, and we're still online, a lot of professors have been able to completely restructure their courses to work online. And so I would say the negative connotation people have to online classes really just comes from the lack of preparation.
Totally.
But, we did say for many years, the future of education is online. And suddenly when we have no choice, online education seems to just work. Right?
Strike through the future, the now of education is
yes,
online.
exactly.
and actually, it's great that you mentioned that, because it goes precisely to the point of Joe Speed, who was also on the show a couple of episodes ago, where he said that, COVID hasn't really changed anything in terms of, what we're innovating and how we're doing it. It's only changed the timescales, right? Some things that were going to be done 10 years from now are being done in weeks, but some things that were going to be done in weeks are now being done 10 years from now because we don't need them anymore because of COVID, right? So the pandemic has shifted priorities, not introduced new ones necessarily. Well, in some cases it has, but as a general rule, it's shifted a lot.
It's the Turing to our Pascal. That's what it is. Ray tracing will happen in 10 years. We're doing it today.
That is such a great analogy.
So exactly that. To go off of that analogy, it's like, that's what NVIDIA did with ray tracing. It's like, here's this thing that was always a focus in the future. Let's just do it now, sort of thing. And they accelerated that with their Turing architecture. So it was always, in the pipeline eventually. Oh yeah, games can do real-time ray tracing, but they were sort of, they weren't really forced, but they made it a priority to let's just do it now. How can we accelerate that? And that's really all the pandemic has done. Nothing is really changed per se. No one's walked out of a lab and said, Eureka, I created this technology that can save us from the virus or whatever. But it's more so like, okay, well, all these things that were going to be online anyway, might as well just make them online now. And we have a question moving forward from Suryanash. I hope I'm pronouncing it right. And that question is, how much mathematics knowledge does one require for machine learning coding? And you and I have already talked about this extensively.
Very
So
extensively.
let's see what you say to the people.
So, what I would say is that first of all, you got to define machine learning coding. And the reason I say that is because there's two ways of doing machine learning coding that a lot of people sort of group into one, which is very inaccurate. One of the ways is to say, I'm a developer, I'm making an application. One of the components requires a certain capability. I don't care how that capability works, I just need that capability. So for example, I'm building an application that can give you feedback on the way that you play table tennis. So you set up your phone on a tripod, you play table tennis, it tracks the way that you move and it gives you feedback. Now, this application would require machine learning capabilities to figure out where the person is in the image, to track them, and then to give you the raw output of their pose that you can use with your own algorithms to go ahead and give them feedback. In that case, you're not really doing machine learning coding as much as you are using an API that happens to be backed by machine learning. And so in that case, as long as you can call a REST API, you don't really need much more math knowledge. But then you get to the part where you are, well, actually, I would say, I said there's two kinds. There's actually three kinds. Then you have the sort of middle kind, where you have a general understanding of, I want to achieve this certain thing, and I don't really care about the machine learning algorithms that go behind it. So let's just say I want to classify images of cats and dogs. Let's just say no neural network existed to do that, but you know that you need a convolutional neural network. Then sure, you can pull up Keras real quick on your Mac, your M1 Mac, and you can use your GPU on your laptop to quickly train a machine learning model that uses the images that you have to create a classifier. It may not be a state-of-the-art classifier, you may have not invented a new architecture, but it'll more than likely work. And in this case, you don't really need that much math knowledge. Maybe a little bit more helps, like being able to understand a loss function would help, but you don't really need to understand how the gradient descent works and learning rate schedulers and batch sizes and these sorts of things. Then you get to the third, which sort of groups into another fourth one, which is you're doing like actual development and research into machine learning. This is where actually understanding the math behind pretty much all the neural networks that you use is helpful. Because at that point, when you're inventing new architectures or when you're trying to create neural networks that work on tasks that haven't been explored yet, that's where understanding the math and being able to say, if I have an embedding of size 768 here, maybe it's not good because it's going to represent too much information because the way that it's trained makes it so it would overfit because I'm not using dropout. Being able to explain these sorts of things is a lot easier, and being able to do that research is a lot more meaningful when you do understand that math. So I would say that if you just generally want to use machine learning, it's not like a must-have. Right? As long as you can call a REST API, you're more than likely fine. But if you do want to be able to say, all right, I'm going to invent a brand new architecture that can synthesize handwriting tomorrow, then understanding the math of how a mixture density network works and how it's derived and how backpropagation works and these sorts of things suddenly becomes helpful. So it sort of depends on what you want to do is what I would say.
Yeah. And part of it, as an extension of that, there are a lot of people who want to get into machine learning, but they don't want to get into the calculus, statistics, probability, and linear algebra that's involved. And I would say, I've talked to Tanmay about this before. It's you can be a great machine learning developer, but sometimes there are things that you might know pretty well that still kind of just seem like a black box because you don't really know what's happening from the math perspective. And this is actually a classic example of when I say university is so theoretical. There is this course in my university called Introduction to Machine Learning. And I have, because I will be taking it in like 2 years time, I have a friend who was able to show me like, oh, here what the assignments kind of look like when I was taking it. And I was going over with Tanmay, and it was a very interesting story. So the very first assignment, this is the very beginning of the course, the very first question that you get, I have, Tanmay is a machine learning expert. I'll just ask him, but he didn't know how to do it. And it wasn't that it's some, machine learning concept that he doesn't understand. It's the question is literally, suppose that you have
number of dimensions greater than n, then prove that x transpose times x will not be invertible, and explain what happens to the least square bubble. So it's literally purely linear algebra. And so this is an introduction to machine learning course. And the very first thing you get into is prove that delta it's like x transpose delta equals 0 for all delta equals x w to the ls minus. So it's literally pure linear algebra for the first question, and then the next question is no help either. It's pure statistics. And so even though this is the intro to machine learning course, they're not hitting us straight with, okay, let's do the flower example and go through that. They're literally teaching you the math behind everything, and that's important if you wanted to, like Tanmay said, study it at a higher level where you wanted to create something new from scratch. It's very important to understand the math. If you're going to be working with machine learning regularly, to pick up on the math and understand at least what's happening on some level. But again, if you're just going to be calling some API or some package for part of your app, it's not really necessary. So it depends on how deep into machine learning that you actually want to get into. Mm-hmm. But if you want to use it regularly, having an understanding of what's happening can be quite important for using the tools effectively.
Precisely, and that's exactly why, actually, if you take a look at the Learn Deep Learning from Scratch series, while I'm not going to show people whatever that question was, I don't even remember what it was. I don't show people how to do that, but I do show people, here's what a derivative of a function is. Here's how it's not necessarily calculated, but here's how, once you have a derivative function, you can use it to optimize that function. But wait, what if we use that for dimensionality reduction? And it doesn't seem like dimensionality reduction at first is related to deep learning, but then you start to realize that, hey, by doing that, you practice gradient descent, and you start to understand the fact that data has dimensions, right? And so this sort of math knowledge is pretty important to deep learning, and being able to apply it and understand it is important, even if you don't necessarily understand, like, if you don't necessarily want to invent brand new architectures, you just want to use deep learning, you don't necessarily need to understand the exact way that automatic differentiation is able to find the derivative of your function, as long as you know it is able to, and this is what the derivative does, this is how it behaves, right? Being able to understand that level of it without having to go too deep into the fundamental math can even be enough in some cases. So it really depends on what you want to do.
Yes, absolutely. But it's always almost, it's like that meme basically, where it's like, yeah, a lot of people want to get into machine learning, but they don't want to do the math behind it.
Yeah, there's almost like the steps of, there was the one image with the kid, jumping over like 6 steps on a staircase, and it's like he's the new programmer, and then there's like classes and structures and objects and functions and machine learning, just skipping straight to machine learning. So yeah, you want to not do that.
We have another question from Ceasley, who asks, how is technology impacting humans' thoughts, feelings, and emotions? How do you see technology shaping these in the future?
I love that question, because technology does impact human thoughts, feelings, and emotions quite a bit. Absolutely. I would say that, emotions and emotions generally, right? The way that we think as humans are mostly controlled by us subconsciously, right? Consciously, we do have some sort of control over it, or at least we can realize what kind of emotions we do feel. But a lot of it is subconscious. It's handled by your system 1, not your system 2, right? They're actual technical terms. The thing about that is that humans have evolved, once again, for millions of years in the wild where technology doesn't exist. And the thing is, we as humans are quite literally suffering from success. You see, the thing is that we have innovated so much in so little time. Any other animal innovates so slowly on the large scale of things, right? That they have enough time to evolve with natural selection to work with their innovation very well. We didn't have that opportunity because we're 8 billion people, and in less than 100 years, the span of 1.5, maybe 2 lifetimes, or not lifetimes, generations of people, right? Yeah. We went from having basically no just portable general technology that we use to having Apple Watches with infinitely more compute than what put humans on the moon. It still surprises me that I can say the wake word and the watch picks it up and is able to talk to me like that.
I love how you
even,
just call it the wake word.
because I got to. But the fact that I can do that still surprises me, and I'm a developer and I understand how that works. It still surprises me. But the thing is that humans haven't had that opportunity. Like when we interact with technology today, like with a computer, for example, it's been proven by MRIs that subconsciously our brain will run the same sort of general activity subconsciously as it would when you talk to another human, when you talk to your friend, or when you're interacting with a pet. So to your brain, computers are just other living things. And that's an issue because now we have these neural networks like GPT-3 that are over here generating text, and our brains are already really biased to thinking that these are living things. And when we see GPT generating text, our brains are subconsciously like, that has to be intelligent. And I mean, it isn't. We understand that. Like when you talk to Google Home, for example, when you talk to a Google Home, you know that the smart speaker isn't intelligent. It's not a human. But even I, as a developer, will sometimes talk to it and think, there has to be something intelligent back there.
It's like the guy with the butterfly meme. Is this intelligence?
Exactly. I mean, even as a developer, sometimes I'll be like, wow, the fact that we can understand language, that it will just innately pique my curiosity. And the thing is that there's nothing we can really do about it except for know consciously that, well, technology is technology, and that the way that it impacts your emotions has to be consciously limited. Technology mostly is being used as a tool today, I would say at a very large scale, to facilitate communication in a way between lots and lots of different humans. And that can have a lot of different emotional sort of impact. Like, for example, Instagram making the decision to hide the number of likes on certain posts for like mental health concerns or whatever, right? Like, they can have different emotional impact based on what you see or how you interact with other people at such a large scale. But I will say that there's not much that we can really actively do about it except for shape the technology in a way to not toy with our emotions that much. And also consciously make the realization that we're working with technology and not people. Those are really the only two things that we can do. Then again, that gets into a whole other discussion of like social media companies, how are they gonna, or why would they want to do that if they're not earning money when they're doing that? That's a whole other thing. But objectively, that's what we need to do. How we do it, why we do it, that's a separate discussion. Objectively, that's what we need to do. But that's generally what I see.
Yeah, there's technology is very interesting because of the effects that it has on us. We've seen, addiction to technology is real. Addiction to social media is real. We've seen how these social media platforms, it's always social media that's a big topic because usually when someone has technology, it's what they're using it for. And you've seen how social media is designed to, give you dopamine and give you certain feelings in the way it presents information and what you're able to do on these platforms. And again, that's part of the reasons they hide likes, for example. They hide likes on Instagram. They hide likes to other people. So if Tanmay makes a post, I can't see how many likes it gets, but Tanmay can still see how many likes it gets. So the effect it has on the actual user making the post hasn't really changed. But it does, have a slight effect because they can't compare themselves to others. They can still say, oh, I posted a picture, it only got 20 likes, for example. They can still sort of make these sort of comments, but you can't say, oh, I got 20 likes. Meanwhile, James got 50 likes or whatever the case. So it still has, these effects on us, and they're designed to create, at least with social media, it's designed to create addiction because a lot of people think, for example, that these companies are selling your data, and what they want is your data. And yes, but it's not like they're making a profile, packaging it up, and sending it to the first, the highest bidder. What they want is your time.
Facebook kind of
yes,
is.
yeah, Facebook should not exist. But
okay, we can all agree on that.
But what they're really doing, right, even technically in what Facebook is doing, is they want your time, because the more time they have of you, the more data that they can collect on what pictures you swipe or whatever the case.
Here's the paradox. Well, not paradox necessarily, but here's the thing: the more the data they can get on you to sell to the highest bidder, the more of your time they can keep.
They're able to
Because the more
extract from you.
targeted
Yeah,
the advertisements are, the more of the
exactly.
time you're going to spend on the website looking at those ads. So
Exactly. And
sort
so
of is a
again, I don't
self-fulfilling
know about
prophecy almost.
Facebook specifically because they're Facebook, but most social media platforms, they're not literally saying, okay, here is Michael and here's this information here, buy it. What they're really saying is, hey, if you want to post an ad, we have a bunch of profiles on people and we know exactly who to give this ad to. So that's what they mean by selling your data, is they're selling this idea that we will show, advertisements specific to you because we have this profile on you. And so when someone says, hey, we want to pay $100,000 to show this to people, we know that you're the kind of person who would click on it because we have this profile of you. And so it can be positive and negative for people's feelings and emotions. I know some people who say they delete social media, and I've done this myself as well. You delete social media for a while, and I don't know, life just seems almost easier. Like things just seem better. You feel a little bit disconnected from people, but it's better on your mental health to delete it every now and then, and come back to it. Take a break, basically. And that's exactly what it comes down to. There are some technology that's really good for you, like video games, right? Video games have been shown to have, if you play video games growing up, there are studies that now say that it has lasting effects on your cognitive abilities as an adult for the rest of your life, right? It has a positive impact if you play video games as a kid. So these are, this is an example of technology that can be good for you. But, then there's technology that can be bad for you. So it really all just depends. And in terms of how it shapes the future, it's like Tanmay said, it's all about our implementation and paying attention to the fact that these aren't people. This is just numbers, ones and zeros. The next question we have from the prognosticator. These are some really cool names. The prognosticator from the chat. It says, so Tanmay, I would really like to know where do you see yourself in 5 to 10 years? Also, please try to answer this question I wanted to ask since the last episode. So we have a burning 2020 question, just as we've advertised. So, we don't lie.
Totally.
Yeah, what do you plan on doing in the next 5 to 10 years?
For sure. I'd love to answer the question. Sorry we couldn't get to it in the last episode. We're glad to get to it now. So let's see here. What do I want to do in 5 to 10 years? So one thing that I will say is that what I love working with is technology. And technology moves so quickly that I couldn't tell you what's happening next month. Well, not literally. I mean, I could tell you generally what my plans are, but you never know when someone's going to have a brand new idea or a brand new neural network from some sort of company or a brand new architecture that just completely changes everything and just, completely wipes away all the plans that we've had. So I will say that overall, there are a couple of goals that I have that I want to sort of work towards. One of them has been a goal that I've been working towards for some time now, actually, and that is to reach out to and really to help at least 100,000 aspiring coders to really help them innovate. And that's something that I've been working towards through many different media. There's of course the 3 books that I've authored, and through these 3 books, teaching all sorts of concepts from like Julia programming to learning how to code in Swift to learning how to code with IBM Watson to implement AI technology, and then also my YouTube channel, as well as the courses that I make on platforms like Cognitive Class and Coursera. It's these sorts of resources that first of all I want to continue working towards, because I feel no matter how great technology is, if we don't have the developers working to use the technology to solve human problems, it's not really useful anyway. So that's one thing. But also being able to make technology understandable and accessible to a wider range of people that aren't technologists, I think is really important. That's exactly why I'm working on TechLifeSkills. That's exactly why I do keynotes and talks, is because I feel like generally as a society, if we don't understand AI, then we won't be able to make informed decisions as to where we want to go. Or not even just AI, really any technology. We won't be able to make informed decisions as to where we want to go in the future with that tech, how we want to structure society to work around that tech. Because tech is fundamental, right? We have to basically admit that society needs to be structured around how we use technology in that society, because we're humans. Once again, we've evolved to be dependent on technology. It's not a bad thing. It's just something we need to embrace, and it's a good thing. The more technology we have, the more human we are. And so I would say that that's definitely something that I want to continue working towards, as well as actually working on applying this technology in fields where I think it can really make an impact. So 5 to 10 years, where I see myself is scaling up all these initiatives, really trying to make as much content for developers as possible, because I'm a developer at heart, right? I want to help other developers. Being able to write a lot more code and actually apply technology where it makes an impact, right? Projects for developers, healthcare practitioners, for fields of like education, these sorts of things, as well as making technology more understandable for just the average person. So those are the three things I really want to do.
That sounds fantastic. Well, I'm sure no one really cares where I am if I was getting here. So, to add to that, why 100,000? Why is that the number of people?
I'm going to say it was mostly arbitrary. But the thing is, 10,000 seemed like too few to me. Like I went through 10,000 pretty quickly, so I didn't want to have just 10,000. But at the same time, a million is, you know, a pretty large goal. So I wanted to start at something that was large, really made an impact, made a dent, right? Like 10,000 is nothing. That's like a nick on like forgetting the name, iceberg, a nick on an iceberg, right? But you know, I wanted to be able to do something that would at least take a bucket's worth of ice out, but at the same time wasn't about excavating the entire iceberg.
Right.
So that's sort of where the number comes from, as well as just generally the estimates of how many people I would be able to reach, and sort of what the rate of that was. Because this isn't just generally, oh, how many books have I sold, or how many YouTube views do I have, right? That's not it. It is how many people can I help individually, people that have said, I've used your book to do this, or ask me a question and I answer it, or help them in person at a workshop, something like that. So that's sort of where that comes from.
Yeah, that's a solid number for sure. It's definitely better than saying, I want every developer. Everyone has to read my book. No, 100,000 is definitely, you're exactly right. It's enough to make a dent and to make a noticeable impact, but it's not something crazy like a million. You're not going for the YouTube plaques here. You know what I mean?
Yeah, you see, I'm not like a large corporation over here creating like massive amounts of content. I'm an individual entity for now. So until I split into two. No.
Yes, and all of his videos, you see Tanmay Bakshi is owned by IBM. No. So we have a question,
or Google or whatever.
or Google. This channel's been bought by Google, and for financial reasons. No. So we have a question in the chat from Akash, who says Tanmay might not like the fact that people are saying Python is their favorite language, and also Just Program from the chat says get good at Python and then learn a language like Java, probably for in response to someone saying what language should I learn as a starter.
I mean, Michael, you know how I feel about Java.
We feel the same about Java. Don't worry.
That's good. That's good to know that we're on the same page. No, but really though, first of all, there's nothing that I really have against Python in specific, except for the fact that it's not something that I personally really enjoy working with, and it's the kind of language that I think shouldn't get as much attention as it does. But at the same time, I understand why it does. Right, so if you think about Python, really the only sort of selling point of Python to me is just the fact that it's simple. Its portability can easily be matched by other languages today. Its frameworks could easily have been written in other languages. It's not like it has specific language features. As a matter of fact, it has certain language quirks that make it harder, like the global interpreter lock. So I would say that Python in general, good language, nothing really against it. But if you're a beginner and you want to learn a really simple language that isn't statically typed and something that you can write pretty easily, then you have Julia. And the thing about Julia is that it is just-in-time compiled, and the syntax of the language makes it so that this is sort of like the whole joke of Julia, is it walks like Python, but it runs like C. So if you wanted, you could write really slow Julia code that read like Python, but it's still much faster than Python because of the fact that it compiles through LLVM. Or you could write really super like hyper-optimized code in Julia that uses all the sort of compiler tricks and stuff. Or you could go anywhere in between, right? Then we talk about Java. Again, Java, as you mentioned, Michael, is one of those languages that has just been sort of used so much in the enterprise that they kind of are just like, let's just keep using it. If we already have these projects in Java, why learn a new language? Or why should
If
we?
it ain't broke, don't fix it.
Exactly. But then you have to realize that Java compiles through the JVM, so fundamentally there's nothing limiting you to Java. You could just as easily use Kotlin. I've done this many times. I've worked on projects with millions of lines of code before that were written in Java, and these are at like large companies, and instead of writing Java code, which I personally don't really like, I would just write Kotlin code because Kotlin is so much more modern. It almost feels like Swift, but if Swift was designed by a Java developer, it would look like Kotlin, is almost what I think of it. And it compiles to the JVM, so it's 100% interoperable completely naturally with all of your Java code, right? There's no like overhead to it. There's no like weird syntax issues. There's no like more surface area for bugs in the interoperability code. It's just natural. There's no reason not to use it. And it even has Google's backing. And so I would say that if you learn Java for sure, right, and there's nothing against learning Java, use Kotlin. And with Python, I guess you kind of have to use it today because, look, again, same issue. Enterprises already just have so much code in Python. But eventually look into transitioning to a language like Julia or Swift or something that isn't Python. Is compiled, basically, is what I mean, right? It's not against Python, it's against interpreted languages generally. Find something that's compiled, find something that's fast, find something that's safe, right? That doesn't let you say x is equal to 5, x is equal to Tanmay, right? Something that doesn't let you just do that. Something that doesn't have a global interpreter lock, right? These sorts of things. Find a language that doesn't do that.
Yeah, I would say like if you're beyond the point of learning Scratch programming, right? Like if you're too old for that, Python is a good beginner language because of the fact that it reads so easily and it does certain things for you. Like you keep talking about the global interpreter lock, and like the way I see it essentially is it lets you get a better understanding of concepts like what is a variable in coding. How do loops work, even though a loop in Python looks so strange compared to a lot of other languages. But once you get these ideas, then you, as Tanmay said, transition to a language like Swift or Julia. But what I would say, depending on like how old you are, if you're like 12 versus if you're like, let's say 20, you might want to start thinking about what you actually want to do. Like, for example, it doesn't make sense if I go learn HTML and CSS because like, oh, I should learn this programming language, but I never plan on doing anything front end, right? So I would say, for example, if you want to be a game developer, you look into, okay, what are the common languages used in game development? You'll find C++ and C#. So you say, okay, learning one of these languages would be really beneficial to me. And while Swift might be useful in teaching me concepts, for example, no one's looking to hire a Swift developer to write games. I would focus on like C# and C++. So really start to think about what you want to do in tech and don't worry about whether or not you change your mind in the future. It's very common to switch positions in tech, right? And generally programming concepts stay the same throughout languages. It's just more so how you implement it. So, start with something simple, again, like Python, and then think about what you want to actually code with. Who knows? Maybe you might just stay in Python, right? Because whatever it is you want to do just requires Python. And think about where you want to go next and find the language that's most appropriate for it. That's what that comes down to, really.
Totally, right. Finding the language that's most appropriate for your job, I think, is fundamentally very important. If you know that you will want specifically a job working at a specific company, a specific position that requires Java, you're going to be coding in Java. There's nothing you can do about it. But if you do have the freedom to be able to say, you know what, we're starting from scratch, I have freedom to be able to make these technical architecture decisions, that's where I start to sort of say, if you're choosing something like Java, you're making a mistake.
Yeah. I had to explain that to Tanmay. Some of the projects he gets, he has the freedom of picking the language it happens on. I say that's unfortunately not how it works for most people.
I've been fortunate enough to have that freedom. So if you do, at some point in your life, have that freedom, make the right choice. Choose Swift or Julia.
Choose Swift. Choose Swift. There's a meme of Michael Jordan where he says, like, stop it, get some help. That's like, oh, I'm going to make a brand new program in Java. No, but yeah, it's all a preference thing. But yeah, Swift is a great language, especially the new. If you have to do something from scratch, getting into these newer languages, I think, is almost like a future proofing. Like I don't imagine C++ is going to disappear,
Totally.
but you can imagine these incredible languages that are built, really recently are going to have these things that are going to prove useful in the future. That's just the way I see it.
Totally. As a matter of fact, I'm sure that in 20 years I'm going to be like, oh, Swift is such a terrible old language. Use like I don't know, whatever they
Swift
call
plus
it.
plus. And then
God,
they have
that would be
Swift
great.
Sharp, but we don't talk about Swift Sharp.
Oh God, no! Just like we don't talk about C Sharp, and Swift Sharp's gonna have nothing to do with the original Swift too, which is gonna be the funny part. Anyway, but yeah, no. Again, use what's new if you do have the opportunity, because you're gonna be future proofing yourself to have less technical debt in the future.
Yes,
in
absolutely.
20 years, Swift is gonna be like 24 years old. Java's gonna be like double that. So.
Our next question is from Pratik in the chat, who asks, which technology will lead 2021?
Okay. What technology will lead 2021? That's
Blockchain. No, I'm kidding.
That's something that I think requires a lot of thought. And we've already started to get into 2021. We can sort of use the trends of 2020 to sort of predict what's going to happen in 2021. I would personally say that if you were to take a look at like all the different, actually, I'm going to slightly change my answer there. I think one of the main technologies that will lead 2021 is compiler technology. And the reason I say that is because throughout 2020, we've seen the sort of, 2019 and 2020 actually, we've seen the staging of a lot of new projects that will fundamentally change the way that we compute. One of those projects has been the MLIR project from LLVM. And basically what that project is basically, we have Rust that has its two intermediate languages. We have Swift with its own. We have Julia with its own. They all compile to LLVM. But what if they also all had optimizations shared between their intermediate languages, right? So then you get MLIR. And what if you could get Swift to compile directly to XLA instructions so it can run on a Google TPU? Right, that's MLIR. At the same time, we've also seen the emergence of Apple Silicon. Now, pretty fundamentally, the entire computing industry, from consumer to enterprise, has been pretty fixated on x86 for a long time now. And that's just because we're lazy. And so when we compile code for one machine, we don't want to have to, transport code to different machines to compile. We want to transport prepackaged built binaries. And so if every computer speaks the same language, we can pretty easily say, run this binary and it'll just run on your computer. However, when all these different computers speak different languages like ARM or x86 or Z or PowerPC or whatever, suddenly there's an issue there, right? We can't just transport binaries, or the binaries would be extremely fat, which is the technical term, fat binaries. So the thing about Apple Silicon is that it's forcing us almost to be like, oh, now we got to support more than just x86, right? ARM is now high performance. And with that, I think we're just generally going to see a trend of not just better ARM adoption, but even just adoption of more architectures, things like RISC-V, right? Things like IBM Power, IBM Z. We're going to start to see more of an ecosystem of software that supports being run on more than just x86. And I think that's going to be amazing because for a consumer, competition is the best. Right? It's always amazing if there's not just a single company doing something really well. And we've seen what that leads to. Exactly. Intel and NVIDIA. Come on. What are you doing? But, that's exactly what that's exactly the problem that this solves. And so the reason that I think compilers are going to be so huge in 2021 is because we're seeing so many more domain-specific accelerators for AI. And that, of course, is going to require compilers to continue sort of scaling into easier developer experiences and faster code. Right? It's about time the compiler community got into this, which is where Swift for TensorFlow comes in, and LLVM. We're also seeing all these different architectures that are starting to get more popular. Again, compilers are going to be super helpful. And just generally, developers are now wanting simpler languages that are safer, but at the same time are incredibly useful and incredibly fast to run on a lot of different machines, which is where like Rust and Swift and Julia come in. So I would say compilers would be one of the things that are really big, but the kind of thing that not many people look at, right? It's not going to be like your average consumer is going to be like, 2021 was a great year for compilers, wasn't it? Right? Like no one's going to be saying that, right? But it is going to, in the back end, enable a lot of other technologies that are at the forefront to really shine in 2021. In specific, I really do think that we're still in that phase where AI is growing fast enough that it will be one of those leading technologies in 2021, especially with the pandemic. I do believe that with COVID, we're going to want to start to use machine learning a lot more, right? Like even with things like, say, contact tracing. Maybe we want to use technology kind of like Google Duplex, be able to automate these sorts of things. You know, I'm just throwing out ideas here, but it's possible that these are things that people are going to pick up on and actually use and actually go ahead and build. And so overall, I would say that there's going to be a lot of fundamental shifts this year and in the years to come from a back-end perspective that are going to enable the sort of technologies that you see at the forefront, like artificial intelligence, to really make an impact. So while I would say what you're going to see as a consumer, it's going to be AI all the way, right? Other technologies like blockchain, quantum, cloud, they're either too back-end or aren't mature enough to really make that much of an impact yet. But AI is one of those things where you're like, oh, I can talk to my watch now, or oh, my phone now has smart HDR and I can identify what to focus on, right? These sorts of things are really going to make an impact.
Absolutely. My answer is going to be slightly different. I think an emerging technology for 2021, but not necessarily like, I guess maybe this would better answer for like 2022 or 2023. Mm-hmm. But I think one technology that will begin to start taking the lead as we enter the 2020s is hyper automation. This is the one that's creeping up that a lot of people don't actually know about.
Doesn't it kind of relate to machine learning and AI though?
Yeah, it does, but it's specifically the act of automating specific tasks with AI, and it basically it's you can guess in the name, it's like automation but hyper. It's like crazy automation. So it's more so like, yes, it uses AI and machine learning, but it's still in the field of automation. And so technically it's like saying automation is on the rise because you're infusing it with AI. And the reason I want to specify that specifically is because if you look, for example, I once looked into IBM, Accenture, KPMG, Blue Prism, Automation Everywhere, and UiPath. There's 6 companies, and I looked at their different technologies, or and what they plan out throughout the years. Mm-hmm. And if you look at, for example, their focus on cloud, only 2 of these companies, you could say for sure, okay, these companies are focusing on cloud for the future. If you look at their focus on IT, only 3 of these companies, you can say absolutely yes, they have a focus on IT for the future. But when you look at hyper automation, all of them have a very clear focus. You can say definitive yes for 4 of them. One of them is something they've already worked to enable on their platform. And the final one, UiPath, is actually just straight up built for hyper automation. Like they designed it from the start to say, okay, this thing will work with hyper automation. So I think because I do remember like reading into this, it's as we enter these 2020s years, we're definitely going to see the rise of combining already existing AI with automation to be able to create things that are completely brand new.
You see, this is the difference in the way we think. I'm thinking developer, I'm thinking AI, you're thinking business, you're thinking hyper automation.
Yes. Because again, like we could have all these crazy technologies from a developer standpoint, but at the end of the day, what takes lead is what businesses decide to use. Right? Totally. So unfortunately, that's the way it has to be thought of.
Well, no, I disagree. No, that's fine.
Yeah. Our next question in the chat is from Madhav. It says, Tanmay, which field should I go into? I love coding and challenges, and I do love the concept of AI, and its challenges to me are very interesting. Should I go into AI or ML, or which type of variant in it?
Okay. So first of all, it's great to hear that you're interested in the world of programming and coding. That's definitely something that obviously I find very fun as well. And in terms of whether or not you should go into AI and machine learning, I would say that it's important to at least have a high level knowledge of it, because machine learning is one of those technologies that's just used so much in the industry that if you don't have at least some experience using it, it can be it can negatively affect your performance in generally the technology that you create. If you're a developer that doesn't know how to use machine learning, and if you're developing an application, your applications are fundamentally going to be inferior to the ones developed by developers that do know how to use machine learning, just because they can have more, intelligent capabilities within their apps. Now, exactly what those intelligent capabilities are, which kinds of applications need them, that's a different discussion. But what I would say is that it is important to learn at least high level of machine learning and deep learning. Now, traditional machine learning techniques are incredibly useful, but they aren't the kind that average consumers really use that often today with like applications developed by, third-party developers. So generally, I would say in terms of the variant, learn about deep learning specifically. That's the one that's just sort of going to be most globally applicable, because that's what the idea of deep learning is to apply to like all kinds of data, structured and unstructured. And so learn about deep learning if you're interested in the math behind it, or how it works, or developing new architectures. You could even just specialize in the actual machine learning or deep learning code. But if it's not something that you're passionate about, at least do get some experience working with it high level. As a matter of fact, if you would like, you could even use a resource like, for example, my book on Watson in order to get into this as well, right? And so what I do is show you just not necessarily how the AI works, like nowhere in here do I actually explain the math behind Watson, just how to call Watson, what kinds of capabilities it gives you, what kind of results you can expect, that kind of thing. And so that will give you enough of a head start to be able to make your apps intelligent. So I would say it would be fun it would be important actually for you to get into deep learning at least some level.
Absolutely. I completely agree. I don't have anything to add. I completely agree. That was perfect. We have a question from the chat. Just Program asks, do you have any tips for starting a programming channel? I started a channel 2 years ago, but really got into it around May 2020. Any tips on how to grow it?
Okay. Well, one thing that I will say is that how to grow a channel. See, that's not necessarily my area of expertise, because personally what I do is, again, as I mentioned, I'm a developer at heart. And so I create the kind of content that fascinates me, right? Like, for example, if I wake up one day and I realize, hey, I could use SIMD vector instructions to make a really fast hangman bot. And if I build it and I realize that, hey, the compiler is doing the SIMD vectorization for me, I'll make a YouTube video about it. But so that's quite literally my thought process. And then there's some other times where I will actually have like a more sort of, I guess you could say, traditionally structured video where I'm like, oh, I want to explain this thing. Now, how can I do it? What can I build? So in terms of how to grow it, one thing that I will say is, first of all, you got to be making videos on something that you are interested in. If I wasn't passionate about programming, and if I were running a programming channel, I wouldn't be running it after a couple days because I would just be so annoyed by having to do it that I wouldn't want to do it.
Right.
So that's one thing that I will say. You just got into it more seriously, as you mentioned, around May 2020. So really what I'll say is make videos on things that interest you, but also interest your target audience. Like, so have an idea as to who's watching your videos, make videos related to things that they would want to learn about and that you're interested in. Like, if you take a look at a Venn diagram of like things that you're interested in, things that your viewers are interested in, find that intersection, make videos on that intersection. That's what's going to grow your channel the quickest, as far as I can tell. It's really high level advice, I understand, but I'm not a business person. I just go. No, but
this is where my years of training step in.
Yes, exactly.
Because I so most of you probably don't know, I am studying an innovation minor at my university. So we're like specifically focusing on innovation, entrepreneurship, startups, and innovating inside of an already existing company, and the whole works. And so if you want to have like, one of the things I've mentioned to Tanmay before is, if you're making a YouTube channel just for fun, like your goal is not to be the next PewDiePie or to make millions of dollars, you have to be careful, because even if you're just doing it for fun, you have to treat YouTube as a business. Not because, again, you're not trying to get the most amount of money possible from your ads or whatever, but while you're making a channel for fun, other people are going to make similar channels with the goal of making money, and so they're going to treat it as a business. So as a result, right, you with your coding channel, for example, Just Program, you might be competing with people like Bulletberry and all these other people who make coding videos. And there's that one guy who's really popular. It's like, oh, I'm an ex-Googler, ex-Facebook, right? So you're going to be competing with these channels who, YouTube is their everyday. That's how they pay their bills. So they have to treat it as a business. Meanwhile, you're just doing it for fun, let's say. So the first thing you have to ask yourself, is almost putting yourself in a business mindset is, who is my target audience, right? Tanmay mentioned, make sure your videos are right for your target audience. Who are you making videos for? Is this introductory programmers, right? Young developers who want to get into the field? Are you making videos for the experts and you're going to talk about the history of compilers or whatever the case, right? So who are you making your videos for? That's the important part. The second thing you might need to ask is, who your videos are for, but what kind of content am I going to create for these people? What is this thing that I'm doing that people can't go to another channel for? Right? Like, what do you bring to the table? What is the style of your videos, or maybe the topic of your videos that you just can't get anywhere else? I sent to Tanmay a video last night because I thought it was pretty cool. There is a video about the inverse square root algorithm that exists in the Quake 3. I don't know if it's in the engine or just the way the game itself works. But there is an algorithm, some pretty smart algorithm somebody invented for calculating inverse square roots. And that's really cool. But the channel that it was uploaded on, that's the only video on that channel. And that channel is already like almost at 100,000 subscribers. And that video has hundreds of thousands of views because that's a niche topic to talk about. And they did a very good job putting that video together. It was styled really well and it felt really unique. And so, I know that without even remembering what this channel's name is, if I came across another one of their videos, if they ever upload in the future, I'd easily recognize it because it has its own style to it. So what it comes down to is, to grow your channel, you need to be unique. You need to focus on, your audience. Don't try and please anyone. And the easy part about that is anything that you like, other people like as well. So don't try to do something that you're not good at, or, be something you're not. Just be yourself, and people who are like you will find your channel. So that's sort of, what I mean by think of it as a business. Is it's not about the money, but think about, how do I attract an audience? Because if they're not watching you, they're watching somebody else. And if they're watching code videos, you want them to watch you. So you need to think about, like, who am I really making these videos for? What kind of content do I want to make? And that sort of, and if you put yourself in that mindset and really pause yourself, take the time to really think about that and write it down, even if you have to, and then think about, okay, what videos can I make that attract to that audience and attract to the things I like doing? Then you're very easily on your way to having a great channel. A lot of people think you need 4K this and high definition that and expensive gear. You don't need any of that. You just need good quality content. Yeah. That's a question I wanted to answer just in general. So I figured I'd bring that up.
Totally.
The next question is once again from the prognosticator. It says, hey, Tanmay, how many languages do you know and how many do you have learned by heart? Of course, programming languages.
English, no.
Did you mean Python? No.
Python is basically just pseudocode. No, it's like if you were to convert English to a programming language, you get Python. No. So in terms of how many languages do I know, like ones that I could pretty fluently code in without using a compiler, like writing on a piece of paper, probably Swift, Python, and let's see here, what else? And Go. So Swift, Python, and Go would be the ones that I would be like, I can sit down offline and more than likely, and probably C as well, C. Those four languages I could just sort of like sit down, pen and paper, write down stuff that would more than likely compile. Maybe with a couple of syntax errors here and there, maybe missing a semicolon or something.
Tab indentation.
How would that even work on paper? Anyway, but then apart from that, I will say that it doesn't really matter how many I know by heart, because never in the real world am I going to sit down and write code on paper. Even if I only know these four languages by heart, remember that if you were to ask me to code in Rust tomorrow, I more than likely could just Google up, taking a look at a couple of different example applications in Rust, understand how some of the basic concepts translate from these other 4 languages to Rust, and then start coding some basic applications in Rust. It's not like I'm fundamentally, stuck at just these 4 languages. I still have the capability to do a lot more, except maybe I'll need to Google a few things here and there, especially when the syntax is pretty different. So for example, Julia has a lot of different quirks, like for example, the array start at 1. And a lot of the time, when I will have not coded in Julia for a couple of days and I'll code again, I'll be like, okay, so I'm gonna index this at 0, and then I'll realize, oh god, no, I have to index it at 1. So, there are things like this where there's some little quirks or such that you may need to Stack Overflow or Google or just sort of think about for a second until you get it. So while I do have a couple of languages sort of that I just know, it doesn't really matter because in the real world, it should be pretty easy to apply the general concepts that you learn across languages. Now, Rust is a bit of an exception because the way that they handle memory is just completely different. There's a lot of translation that needs to happen, but overall, that's the general idea. Is it really doesn't matter.
Fantastic. Absolutely. And just to sort of add on to that, again, generally speaking, if there's a programming concept that exists, it likely exists in other languages as well, especially when you're talking about general object-oriented programming, right? A lot of these languages fall into that title for a reason.
Swift is protocol-oriented.
But so essentially, for example, if you're looking at 2 object-oriented languages, as long as they both have a concept, let's say structures, for example, as long as they both have structures, it's not like you have to completely rethink the way you use structures. It's just like, okay, how do I use it in this language when I'm used to using it in this language?
Java doesn't have structures in its object-oriented. No, I'm joking, but yeah.
Java is just Java. No. So we have a question from Shiva in the chat who asks, what are your views on edge computing's popularity?
Ooh, okay. This is a fun topic, and we're going to be covering more on edge computing on the show soon. I do believe, Shiva, you also sent me a question about TinyML and a couple of other things over email. And first of all, I will say edge computing is a really interesting topic, and I personally am very interested in it. Specifically, not even just the kind of edge computing that you think about usually. Like, for example, traditionally edge computing you think of running a machine learning model on an M1 MacBook Air or on an iPhone or on an Apple Watch or something. But edge computing is even just running a machine learning algorithm on a certain sensor board running on an aircraft engine, right? So these are the sorts of places where edge computing can make an impact. Machine learning algorithms are traditionally very heavyweight, but I am definitely very interested in seeing how deep learning algorithms, specifically, not even just machine learning, deep learning algorithms, can be sort of made to be more lightweight, to run on mobile devices. Your goals are really, I would say that whether or not you would do that, or even how you would do that, depend on the goals of your model. For example, there's a project that I'm working on, you'll hear more about it on Jan 9, that needs to be extremely accurate as its #1 priority, but also needs to be fast. And so therefore, I'm fine with saying, okay, I'll give you 1 billion parameters instead of 1 million, but I'll also give you 6 GPUs to run on at the same time. But then there are also some applications where you can sacrifice a little bit of accuracy in order to have a better system. For example, did you know the way that I was about to say the word, I shouldn't say that. The way that the wake word works on iPhone and Apple Watch is when you say the 2 magic words, there is a super, super tiny neural network that has very bad accuracy, honestly, working on your device locally. What happens is, when it detects that you say the 2 words, and it's always running, constantly, and it's so lightweight that it basically never touches your power, and it's running constantly. It has I think it's an 80% accuracy rating. Whenever it detects that you say the 2 words, it'll pop up the Siri interface and it'll start listening to you as if you did say the 2 words. And at the same time, as that pops up, it'll take the recording of the wake word and send it to an Apple server where they do a more accurate sort of calculation to see if you said the wake word. And if it turns out that the machine learning model initially made the incorrect decision, Apple will tell your phone, close the Siri interface, it didn't actually say that. But if it was right, then it'll keep the Siri interface open. Everything goes on normally. So, edge computing is really important, which is why I think it's great that it's popular, right? And so imagine if you couldn't say those two magic words and open up Siri, right? If you were in a car and you had to open up Siri, imagine if you had to actually pull out your phone and turn on Siri. It would be pointless. That defeats the entire purpose of a hands-free interface, right? So it is definitely very important. And it's interesting from a technical perspective as well. It just has some fundamentally different goals versus what most machine learning researchers are interested in, which is how can we get the best models possible. Like all the machine learning researchers sitting over here thinking, how can we make these models better? Let's go to 1 trillion parameters this time. And meanwhile, over here at edge computing, we're like, scale it down a little bit, please. Let's bring it back down to what can run on an ARM Cortex A5. So that can that's edge computing. But you'll be hearing more about it. We will be having a dedicated episode on edge computing on TechLifeSkills very soon. I can't tell you when just yet, but within the next couple of weeks, we will be with a leader in the field that has most likely already been on the show. So it'll be really interesting.
Funny story that reminded me of, not that this is edge computing, but as a joke, this is as edge computing as you could get. With the RTX 3090 being released in September, it has 24 gigabytes of video memory. And there's this game called Crysis 3, which only requires 17 gigabytes of disk space. So what one incredible mad lad was able to do was actually get his computer to read his video memory as disk space, install the game onto his GPU, and run the game directly from his GPU. Now, if that's not edge,
hold on, I'll say. The joke is, can your GPU run Crysis? Mine can't just run Crysis, it can store Crysis.
Unfortunately, it didn't really help with the load times because, CPU bandwidth.
Yeah, I got a chance to back to this. Literally what's happening, this is what's hilarious to me. This is what's hilarious, is it's not even doing it directly. It's going from the GPU over PCIe back to the CPU and then back to GPU because the driver's not meant to load it directly. So there's literally no point, but it's possible. How great is modern technology?
In 2077, edge computing, all of it's done on the GPU. There is no need for SSDs. You just use your video memory to store all your data. So our next question is once again from Shiva in the chat. Tanmay, I am keen to know, are you a morning person or a night one?
I generally more productive at night, but I do like waking up in the morning. Even though I'm not good at it, I like it. When I do manage to do it, it's good. But overall, though, I do enjoy coding at night, as a lot of developers do, I'm sure.
Yeah, I'm very easily a night person. Tammy saw literally before this, just last night, I was like, oh, it's 4 a.m. I can't go to bed. I don't know. You probably woke up to some like confused messages because it's like I sent him a message at exactly 4 a.m. I'm like, why am I awake? And then it's like 5:10 and it's like, why am I still awake? And I'm like, I meant to send that 10 minutes ago too, so it would be exactly 5, but I missed that window. Like, I don't know. Because I have to wake up like for school and stuff in the mornings, right? So everyone to some degree has to be up in the morning. But whenever I get the opportunity, my body will naturally just be like, okay, you're gonna be up all night. Have fun going to bed at 6 a.m, waking up at 4 p.m. So yeah, that it's very interesting. I think there's studies that show like creative people are night owls and that kind of stuff. So yeah, I guess Tammy's a night owl then.
And you're left-handed. Are you left-handed or am I thinking of someone else?
Yes, I am left-handed.
You are. I keep forgetting that.
I write with my right, so it does trip people up. I learned to write with my right hand. Okay. I don't know. That's just how I was taught. I was learning to write with my right hand. It's it's funny. So like for example, I'm raised Catholic, so like you do this thing when you start a prayer called the sign of the cross, and you take your right hand and you go Father, Son, Holy Spirit. Wow. But when someone's doing it to you, right, it's kind of flipped. And me being left-handed, I just did it with my left hand at all times. Oh, yeah. Apparently, that's a very big no-no to the church. So. Growing up, I was just like, yeah, left hand, because that's what I am. And I guess I sort of had to learn just to start doing things with my right hand. Like I use a mouse with my right hand. Like I didn't know left-handed mice like were a thing, right? Like I I use a mouse, trackpad, all the stuff. I do that with my right hand, but I am left-handed at heart. We have Labib in the chat. Hello, Labib.
Hello.
Good to see you. He says, hey, Tanmay, I hope you're doing well. Do you still leak code? If so, how many problems do you usually try to solve? And how would you get better at solving them? Like, what approach would you go for?
Michael can vouch for the fact that this is a really fun hobby and just something that I do for fun.
Tanmay's like, get on a call. We need to leak code.
Yeah, when there's nothing else to do, why when I'm done with my fix of like table tennis or biking or whatever, and I want to have fun, it's like pull up leak code. Let's see what we can solve. But I will say that leak code is interesting to sort of challenge your problem solving skills. A lot of their problems though aren't programming problems per se. They are, can you solve this riddle? And can you also happen to code it, but can you solve this riddle? Never in a million years is an employer going to ask you to write code in an enterprise application that determines the happy prefixes of a string. All right?
It's only for the interview.
And that's not even something that translates to a real algorithm either. It's not like this is just, a proto version of some real algorithm in somewhere. No, it's just not applicable. Straight up, it's not. So I will say that it's really nice as just a fun challenge. Some of the problems are really interesting from a programming perspective. However, for real world applications, being really, really good at leak code and being able to solve them really fast and getting into the 100% top speed, well, maybe that's different, but solving them really fast and solving all of them doesn't translate to being a great programmer, right? It's pretty much the same thing as, if you're an Olympic swimmer, that doesn't mean you're going to be the best Navy officer, right? That doesn't translate. So you may be really, really good at swimming in the specific environment of the Olympics, but that doesn't translate to you being good in the Navy as an officer, right? So
Olympic swimmers might not be the best lifeguards. They don't have the CPR training.
Exactly.
They don't have, right?
Exactly. So that's what I would say. Leak code is very much trying to overfit your neural network to working in that very specific environment of here's the exact problem and solution, and it's not even related to programming. It's just its own riddle. See if you can code it really fast. That's it. But it is still fun. It can still be helpful. It can still challenge you. So I don't encourage you not to do it. In fact, there might be some more content on my YouTube channel on that soon. Stay tuned. But don't treat it as something that's going to translate to real world applications. So that's what I would recommend. But thanks for sending in the question, Labib.
Yeah, it's absolutely. Yeah, it's good to hear from you again, Labib. And it's definitely... It's a good way to like tease your brain and to sort of build critical thinking skills, but it is at the same time non-indicative of your abilities as a developer. Mm-hmm. But it is a good way to keep testing yourself and, how you would approach different problems. But just because you can solve leak code problems does not mean you're, great for a team of developers. Our next question from Hiroshika in chats is how to know when you have become an expert in AI and data science. Any signs? How do you know that you're on the right track when you're assessing your progress, when you can, really get lost in wonder?
So, first of all, it's really hard to say, this is how you know you're an expert, because there's never really one point where you can say, now I'm an expert, right? It's sort of just something.
Boys, expert.
It's really something that evolves over time, right? It's something that you sort of start to eventually realize by the work that you do and by the things that you build, not necessarily as, I just finished my last cognitive class course, I'm now an AI expert, right? So I would say that what you should do is really learn in a way where you learn through example. Build projects that you're interested in, right? Do things that you find fun. Solve problems that you have fun solving. And by doing so, you will end up gaining enough experience And when you are able to solve problems that you deem complex or problems that you think, maybe a month ago I couldn't have done that, that's how you know you're progressing, right? Like, perfect example, back in like August of 2019, I worked on this 2048 bot that could play 2048. And at the time, I thought it was the fastest in the world. It could get 64 moves a second. And it was really fast. I did this for a cognitive class course, actually, to create the course. And someone else blew my score out of the water. And a couple months ago, I blew their score out of the water with a bot that could get like 8,000 moves a second instead of 64.
And they shall know defeat. Never again will they dare try to cross my machine learning capability.
They bested me, then I bested them. No, but but seriously though, over time you just sort of gain this experience. Back then, I was still pretty good at Swift, right? I could still develop like full stack apps in Swift. But now I'm just better. And it's not like I am an expert now or I wasn't an expert back then, but I just had generally more experience with programming and CPUs and compilers and optimization to be able to say, this is how I can make it faster. So that's, I would say that the signs would be when you start to be able to solve problems that you say, oh, a month ago, 2 months ago, a year ago, I couldn't solve that. That's how you know you're progressing. And that's why learning from examples is so great.
And sort of to add on to that, the tricky part about saying I'm an expert in AI or an expert in data science is these are both very broad terms. You have to remember any sort of disruptive technology, the blockchains and quantum, these are very broad, not in the sense it's like, oh, well, data science can split off into a trillion things, but what does it mean to be an expert in data science, right? That you just know everything about data science, right? It's a lot of these fields can be broken down into smaller fields, and people tend to be experts in these smaller fields. That's like saying I'm an expert in physics. What does that mean? There's quantum physics, classical physics, astronomy. There's so many different areas of physics. What does it just mean to be a master of physics? Doesn't make any sense, right? So if you are looking into, hey, I want to be an expert in AI and data science. Well, what about AI, right? Because there's machine learning, there's neural networks, there's so many different things. And then even, for example, in neural networks, you have natural language, you have processing and generation, and there's all these different fields. So what does it mean to be an AI expert? What does it mean to be a data science expert? Generally, when they refer to that, you're an expert in some specific area of this field, but there's no way you know everything about the whole field. Right? There's always going to be stuff to learn. And even that's why as an expert, experts don't just say, all right, I'm done. I'm never reading another book again. I've done it. That's all the knowledge there is to know, right? Experts are still constantly learning because you're an expert, but in something very, I don't want to use the word niche, but something very specific. And so there are still things outside of that bubble still within your field that you can always learn about.
100%.
Just to add on to that. We have a question in chat from Venkat. And this one, let's get straight to the point with this answer. I am 7 years old, having knowledge in Java, Python database, JavaScript, HTML, and CSS. Well, these languages going to help me learn Watson? Are these languages going to be useful for learning Watson?
So I will say that you said Java, Python, databases, JavaScript. Of these, the one that I think will be most helpful for you for Watson, also thank you for sending in the question, Venkat. That was, it's great to get to answer your question. Python will be the most helpful for you. And the reason I say that is because Python is the simplest language to be able to call into APIs like IBM Watson. And so I would recommend, using different resources like Cognitive Class is a great one, or my book written with the CTO of Watson, in order to learn about how to actually call into those APIs through Python. Oh, as a matter of fact, this book actually we do call all these APIs through Python. So. And so what I would recommend is using the Python language that you've already learned in order to be able to call Watson and use AI capabilities. And that's also going to help you learn more Python as well as you learn how to call Watson, and that will help you explore other languages too. So thank you very much, Venkat Raman from the chat. Hopefully that was helpful.
Yeah, Venkat, and at 7 years old, you're doing a great job learning all those things. It's definitely way more than I ever learned. And so our next question is from the chat. Once again, we have Labib. Labib asks Tanmay, are you going to continue the deep learning series? Do I need to have a certain foundation to start your series? And also, how do you keep yourself motivated to manage time management or to manage time during quarantine? This is a lot of questions, so we'll probably have to go through them one by one, but what are your projects and ideas for beginners ML? Are there any other for software development, like app development or web development? What are your first projects, if you don't mind sharing? So let's start with the first line. are you going to continue your deep learning series?
Sure. So I'll keep these ones brief so I can actually get to all of your questions. But first of all, am I going to continue the series? For sure. New content coming out soon. Actually, a lot of new content coming out soon in that series. So do stay tuned for that. Do you need to have a certain foundation to start? Not necessarily. I believe that, I mean, I know you, Labib, so the level that you're at is more than enough for this. But just so everyone can sort of understand, as long as you have some basic mathematical knowledge, you know what mathematical functions are, you know how to plot a function, and as long as you have some kind of programming experience with Python, you know, you understand how classes and references and, you know, list comprehensions work, these sorts of things, you're good to go. So that's, you know, pretty basic Python knowledge is also important for the series as we get into the more practical aspects. And in terms of project ideas, I would say, well, for machine learning in specific, starting off with something super classic, and I know this seems like, oh, everybody says this, but starting off with something super classic like MNIST is nice because it gives you a bit of a feel for how this sort of stuff works. But the only thing is, don't fall into the same sort of leak code trap where you overfit yourself to solving Kaggle challenges, right? Or you overfit yourself to MNIST and Iris. What you want to do is get experience working with a wider variety of data sets. One of my first projects was MNIST digit classification. But then from there, maybe what you want to do is start to explore exotic architectures using similar data sets. So for example, build a triplet neural network to cluster digits together instead of classifying them. Maybe you want to use that same triplet neural network to then do movie recommendation with the movie lens data set. Maybe then you want to see what the difference is between that and a regular collaborative filtering algorithm's performance using to recreate. These are the sort of things that I would say are nice to start off with in terms of machine learning. In terms of other projects, I honestly think that the best way to learn like general development is just by implementing pretty simple algorithms that are programmatically complex, not necessarily super like riddles like LeetCode gives you, right? Being able to say, here's a linked list with digits in them, and I want you to take these two linked lists and manually add the two numbers that they represent. That's a pretty good example of a problem that actually does force you to sort of think programmatically. Maybe another question like, can you implement the sieve of Eratosthenes and optimize it to be as fast as possible? And can you get it to give you the result for a certain number, right? So instead of just generating a certain number of random, or going up to certain, like n, and finding all the prime numbers up to n, can you give me the nth prime number instead? And how can you optimize your code to do that? These sorts of challenges that are, you know, programmatically as well as logically complex are the ones that I think are most valuable. And also, how do I manage time during quarantine? Honestly, what I do is really fun. And, you know, I'm coding, I'm creating YouTube content, I'm writing books, I'm doing these sorts of things. And so because of the fact that what I do is just kind of fun, it's the sort of stuff that I want to do, it mostly just comes sort of naturally, I would say. Although I will also say that it's a lot easier to manage time not in quarantine, right? Because then you have a lot more scope to be able to work with people, do things in person, get things done more quickly, more efficiently, more effectively. But, you know, working with what we have right now, I will say that maybe, you know, if you were to sort of force yourself to look at the positive side of things, you know, now you're not spending as much time outside driving to different places, you're not spending time commuting like that. So managing time really just comes from the fact that I love doing what I do. And then of course there's some parts of it, obviously, that maybe I don't find as exciting as other parts. But just keeping in mind that those parts, by working on them, I'm sort of working towards a goal of getting something that I do enjoy done. It sort of gets you through it. You know, like for example, I'll be implementing a machine learning application and I'll think, God, no, I've got to write 200 lines of code just to process my data set to get it in the right format. But then I'll remember, you know what? I'm going to have X model done by the end of this, so it's worth it. And I'll do it. So, you know, it's a lot of coding and a lot of programming is literally just that repetitive infrastructural coding. But regardless,
absolutely,
it's fun to see the output.
What I always default to for projects, at least going back to that really quickly, what I always default to, you know, I don't really do front end development, so like web development, sorry. So like maybe you could use it to draw sprites. And what I say usually for back end is if you're looking for a project to learn a language, for example, just make a game. It's the easiest thing to just default to. It's not an easy task to do, but it forces you to learn basically how the language works.
Yeah.
You know, make a 2D side scroller or 2D whatever, a 2D game, because 3D would be way too complex. Make a 2D game. I don't know, maybe you can use like HTML and CSS to like draw blocks of pixels on a website to make your sprites and then screenshot that sprite. Like if you really want to get into it. But I always say like, oh, you want to learn a new language and you know you don't really know how things work, just make a video game. Make a 2D game. It can be a game that already exists. Just make your own version of it. Tetris, whatever game you want. Just make a 2D game. It forces you to learn, you know, how you would organize the code and how you would do
actually funny
things.
that you mentioned Tetris. That's one of the examples in the new Go book that Omer and I are writing.
That's why I thought of it.
And you know, when you're like me and Omer and you really, really hate front-end development and you just really enjoy back-end development, you can even be like us and maybe even spend more effort than it would take for a front end to build a command line interface for Tetris. So you can do all kinds of things. And we built a command line interface that you'll get to work with in the Go book. So make sure you stay tuned for later this year, middle this year. We're going to have the Go book out for you. You can learn Go, fun examples like Tetris bots in Go. And we also throw a little bit of Swift in there as well. So stay tuned.
That sounds fantastic. Yes, Swift. It's all coming together. But speaking of staying tuned, make sure you stay tuned to this channel for more updates as we close today's AskTanmay special, episode 40. I'd like to thank everyone for tuning in. I am your host, Michael Francis. It was a great time hosting you, Tanmay, and dealing with the audience. Do you have any closing remarks before I give the finale?
You know, I gotta say, first of all, it was really fun doing this first episode of 2021. You know, it's first of all, I mean, as I mentioned, you know, huge thank you to everybody who's been on the show for the past 39 episodes. It's been really insightful to get to learn from all of them, right? All the way from experts in their field to students. It's been incredibly exciting, and of course, huge thank you to everybody joining the stream today and anyone who's joined the streams in the past. Really do appreciate all the questions you send in, all of your feedback. Even today, I'm sure there are some questions that we missed, but we will be covering them in the next Ask Tanmay special. It was also a pretty fun break getting to you know, have you host the episode and I get to answer the questions this time. So thank you for giving me that vacation.
Well, thank you for letting me take over for the day.
Of course. But
yeah, and honestly, you have a very great audience here. They're definitely very engaging and they're asking the right questions. I always say it's very important to ask the right questions, and they seem to all have the right mindset. So it's a pretty cool audience you have here.
Absolutely. Thank you very much, Michael, and thank you, of course, everyone for joining in today. And of course, as always, we will be continuing with TechLifeSkills next week. Next week, we're actually featuring a guest that I'm very excited to speak to. I've been planning this one out for many months now. We are going to be featuring an AI researcher that has really, I would say, some incredible opinions that he shares very openly. he's very outspoken with his opinions on certain topics around AI, natural language processing, OpenAI, GPT, and so on and so forth. You've almost definitely heard of him. He's a really prominent AI researcher. Can't say just yet, but around middle of this week, you will be hearing more about the next episode of TechLifeSkills with Tanmay. So make sure you join us next Sunday at 11 a.m. Eastern Time. I cannot wait for that discussion. We're going to learn so much.
Wow, even I'm excited.
Wonderful, but this time you'll have to join from the audience. You can't join. You can't be the host next week. But there will be another.
I already had my questions prepared.
Send them to me. But there will be, of course, another Ask Tanmay special soon. Of course, I'm really looking forward to that. So make sure everybody get your questions ready for next time, and get your questions ready for Sunday as well. And so, again, thank you very much, Michael, for hosting this. Thank you, everyone, for joining in today, and I will see you next week on the 41st episode of TechLifeSkills with Tanmay. Thank you very much, everyone, and goodbye.
Thank you.